Hello everyone, welcome to this introduction to Python for beginners. This is the very first video that is on this channel. By clicking on this video, you've taken your first steps to becoming a software developer, a web developer, a data scientist, a financial analyst, amongst so many other career options. This is because Python is very well supported by the community. There are lots of packages that make producing graphs, analyzing data, building a neural network all so much easier. Python is a very beginner-friendly language, and this tutorial will not only aim to help you get a good foundational grasp of Python, it will also help you develop that logical mindset you need to become a good programmer. So let's talk a little bit about what Python actually is. Python is a high-level, interactive and interpreted scripting language. So what do these different components actually mean? Well, it's high-level. Python code is several layers away from the actual machine code that your computer's central processing unit executes, thinking ones and zeros. Thankfully, we don't have to write Python code in ones and zeros because it is such a high-level language. It makes it easy for us to read and understand each other's code once we've written it. Python is also interpreted. It does not need to be compiled prior to execution, like you might see in other languages, such as Java or C++. Finally, Python is interactive, which is a consequence of the point before. We can run it as a program, but we can also run it in an interactive way through a shell or through a Jupyter Notebook, which is what you will see in this course. We can develop for Python in a number of different ways and in different environments. You could start by just using a very simple text editor like Notepad. However, it is more common at that point to use something called an IDE, an integrated development environment. Think just a fancy text editor with some sophisticated tools that allow for things like code completion, syntax highlighting, and integrated debugger tools. An alternative for us that is particularly popular in the fields of data science and also for education, like in this video, we tend to use Jupyter Notebooks. Jupyter Notebooks are very useful because they allow us to write code in blocks, and we can execute those blocks individually, but we can also write text alongside it. It's very useful for sharing insights or for helping to deliver educational resources. We're going to cover many different topics throughout this course that will then help you give a good footing so that you can go and explore various other libraries for yourself that can help you do things like building neural networks, as mentioned before, or producing visualizations of data, things like that. We'll cover things like types, collections, loops, functions, but before we cover any of that, we're also going to talk about how we actually set up Python and set up our development environment in this case. I'll now pass it over to other me so that I can talk you through how we actually set up this development environment so that you can follow along, before we then dive into some deeper topics around Python. Hi everyone, and welcome to the first part of this Python tutorial. Now in this part we're just going to get set up. We're actually going to install Python on your system if you don't have it already. If you're already set up with Python and Jupyter Notebook and things like that, please feel free to skip this section of the video. So one thing I want to start by mentioning is that there are a number of different ways of setting up Python, including just installing Python on its own without any packages, or installing something called Anaconda, which includes a bunch of data science oriented packages. That's quite popular amongst the data community because it includes things like pandas for data manipulation, matplotlib and seaborn for visualization, things like that. So this particular way I'm going to show you is not necessarily the way you will want to follow. I think it's particularly useful if you've got an Apple Silicon processor because it is compatible with that. Let's get started. I'm first going to open up a Safari window and I'm going to search for something called MiniForge. Now if I search for it and I click on the first link I see, it takes me to their GitHub page. Now there's a bunch of information about what MiniForge actually is down here, but basically it will allow us to install Python, and it will also come with this thing called Conda. Now Conda is useful because it allows us to create Python environments. And so what are these environment things? Well, basically, if you've got one particular project which has a bunch of packages installed and another project which has these different packages installed, you don't necessarily want them all to be installed in the same place. The reason being is because different packages and different projects might have different dependencies, and you might have to have different versions in each project. it can become a bit of a mess basically. So Conda allows us to create these isolated environments and say, right, for this project we're using this environment and it uses these versions of the packages. That allows us to avoid conflicts basically. So Miniforge is something that comes with Conda, and there's instructions in terms of how you download and install it down here. There are downloads available for different systems. There's Linux, there's OS X, and there's Windows. And as I mentioned before, there is this Apple Silicon build here as well. I'm just going to click on this because I'm on an Apple Silicon machine, and it will start downloading this script. It should be quite quick. Once it's done, you'll see that it's available in the downloads folder. Now, if we want to actually install it, I'm just going to close Safari, and I'm going to open up Terminal. We want to run the sh command, which will allow us to run a shell script. We just need to pass what script it is we want to run. An easy way of doing that is to type sh followed by space, and then take our script and drag it into that terminal window. So now we're saying run this script basically, and by dragging it, it will pass this path to that file for us. You can see that it's in the downloads folder because we downloaded it to there. If I run that, it will ask you to review a license agreement. You're welcome to read this if you really like, but if you hit enter a few times, it will ask you, do you accept the license terms? You can type yes or no. I'm going to type yes. And then it will say Miniforge will now be installed into this location. Press enter to confirm. So you can press enter. You'll notice when I do it, it says it already exists. And if you want to update an existing installation, use that option. So hopefully for you it installs fine, but for me obviously I've already got it installed. So now if I type Python, you should see something like this. This now opens up a Python interpreter for us, and it's on version 3.9.5 in my particular case. Now here we can actually start typing Python commands. We're set up and ready to go in that sense. I can type print hello world, close that off, and that returns hello world to the console. So we can actually use this interpreter to do some basic coding. We're not going to do that necessarily because it's not ideal doing it in here. So what are we going to do? If I press Ctrl D, I can get out of the Python interpreter. One of the other things that Miniforge will install for us is something called a Jupyter Notebook, and you can run it by typing this command, Jupyter-Notebook. If I hit enter, it will start a little Jupyter Notebook server in that terminal window, and it'll also open your browser. So you will now get this UI, and this is the Jupyter UI. So what actually is Jupyter and what are Jupyter Notebooks? It's another way for us to code in Python. It's basically a different type of editor. If you're writing Python code, you may use a text editor. You may use a more sophisticated editor called an IDE, an integrated development environment. And a popular one is PyCharm, for example. Those are quite useful if we're doing like some robust software development. A Jupyter Notebook is an alternative. So in here we can create these notebooks where we can write our code alongside blocks of notes. That makes it particularly useful if you're passing around insights or just for learning as well. You can add your own notes alongside code. It's one of those things that when you see it, it makes sense really. So you can actually create a notebook wherever you like. I'm just going to do it here in the root folder. If I go to new, I can click Python 3. You can also create a text file and folders and stuff, but I'm just going to create this Python 3 notebook. And when you click on it, you'll see this UI. Now you can click the name up here to name it whatever you like. I'm just going to call it my notebook for now. Now you have a few menus here which you're welcome to explore. You can save your notebook, you can edit cells, nothing too interesting in there. You can insert new cells, and you can like run cells, change their type and things like that. So there's a lot of things associated with cells here. Now when you create your Jupyter Notebook, you'll see one cell here. So in this cell we can actually type some code. Now if you want to add new cells, you can obviously go to the menu, or you can click these little buttons down here. This plus button will add a cell. You'll slowly start to learn keyboard shortcuts over time. So B will insert a new cell below. You can spam that if you want, and double tapping D on a cell will remove it. Now you can also change the type of a cell. You might have seen that in this menu. You can go to cell type, change it to code or markdown. Those are the two main ones. So you see this cell has this little IN next to it. I'm going to create a new cell and I'm going to hit the M keyboard shortcut, which will convert it to a markdown cell. So in markdown, we can actually start typing notes. These are some notes, for example. Now, markdown actually supports a lot of different ways of styling your notes. When you run this cell, it will just run the output of whatever you've written here. In this case, it's literally just the text I've typed. But what you can also do is you can add things like headings. So if you use the hash key, you can add headings like this. And if you now run the cell, you can run a cell by clicking the run button, or you may use shift and enter. You'll see we have a heading. So we can do that. We can add bulleted lists like this. So there's a lot of powerful things you can do with Markdown. And you can see that you might be able to add your own notes as you go along, alongside code cells. So now in code cells, we can actually start typing some code. We can type print hello world like we did before, and we can run this cell. We can then go back and change it and rerun it if we wish. So this is quite powerful in the sense that we can now have notes alongside our code. It's very helpful, especially when you're just first getting started. Now, for the remainder of the tutorial, you're welcome to create your own blank notebook like this. I'm actually going to delete this, so I'm going to close and halt, and it'll ask me if I want to leave. If I now go here, I can tick this and click the delete button. Now, for the rest of this course, I've actually created a notebook in advance. I've created two versions of it. One of it has all the notes filled in, but all the code cells empty, so you can code as you go along. The other one is completely filled in case you just want to follow along. I do recommend coding as you go along because it helps you get well practice with actually typing Python code out. And it will just help you retain that information a bit better. You can start a completely new notebook if you wish, or you can go to my GitHub repository, which is linked in the description, and actually download the notebooks, either unfilled or filled. So I'm just going to show you that now. So when you go to the GitHub page, you'll see something like this. If you go into programming/Python, you'll see a couple of these notebooks. These are the unfilled and filled notebooks I was referring to earlier. And if you click on it, it will render it in the UI, although bear in mind it may look a bit different to what it actually is supposed to look like. Now, what you can do is you can, if you're familiar with Git, you can clone this repository, and then all you have to do is in your notebook UI, you can navigate to wherever you've cloned it, open it, and then you're ready to continue with the tutorial. Alternatively, you can come here and you see this raw button. If you click on it, it will actually give you this view of the notebook, which is purely a text file basically. So instead what we can do is we can right click that and click download linked file. Now this will allow us to download that notebook, and I'm just going to save it to the desktop here. Once that's downloaded, we can actually go to back to the UI. If we go to desktop, you'll see that that is the file I've just downloaded. If I click on it, you will see the notebook when it loads. So at this point, you're ready to continue with the tutorial. Obviously, this one is the one that has the code filled in, but you can download the unfilled one and type the code as we go. Hi everyone, and welcome back to part 1 of this Python tutorial. We've had a look at getting Python set up and installed on our system, and we've also had a look at the Jupyter UI. We've looked at how to navigate through notebooks, how to create notebooks. So those are some of the techniques that we're going to be using through the rest of this course. We've already had a little talk about how Python is useful in many different fields, such as data science and machine learning, or software development, or web development. Anywhere you need to analyze or manipulate data or automate tasks, all of this is made much easier by Python. Say, for example, you have a weekly reporting task and you need to make an Excel spreadsheet as part of your job every week. Wouldn't it be much better if we could just automate that so that we can have a Python script that takes an input Excel spreadsheet and modifies it, outputs it, even automatically emails it to your supervisor if required? We can do things like this with Python. We've already discussed how it's a high-level interpreted and interactive scripting language as well. So it's very beginner friendly, And regardless of whether you've done any programming before, this is something you should be able to follow. So we're going to cover a bunch of different sections here: operators, strings, loops, functions, and it's all going to give you this good foundation so that you can understand Python code, you can write Python code, and then you can start exploring some other libraries. So we're going to start with the introduction here, and we've just gone over a lot of this already. Feel free to take your time to read it in more detail if you wish. But we're going to start with some basic syntax. So what does Python code actually look like? So to start with, two particularly important aspects of Python are printing and variable assignment. They're things we're going to be doing quite often. Now, printing something to the console is quite easy. There is a built-in function called print. So we can print a variety of different types, such as integers or floats or strings, and we're going to see what all those different things even mean later on. So this is telling us, let's try to print the integer 5. So we would do that by using the print function, and we would just pass it the number 5. And if we run that cell, we get our 5. So now we don't just necessarily want to print random numbers and letters. We might have done some kind of computation which has now assigned the result to a particular variable, and then we want to print that variable. So it's very useful to store numbers in memory in this case. So in order to do assignment, we use the assignment operator. So I'm going to write a equals 5 here and b equals 10. And then what we're going to do straight after defining those is we're going to print both of those values to see what they are. Now note that you can do the above assignment in a shorthand. You can do something like a comma b equals 5 comma 10, and that'll give you the same result. It's generally preferred to be a bit more explicit in this course just because it's easier to read, really. If you have like a bunch of variables like this, C, D, E, all being defined, it can be a bit hard to read, whereas if you have it line by line, it's a bit clearer. Now sometimes we want to update the value of a variable using the variable itself. This is why I've tried to go into a bit of detail about what this equals is actually doing. It's not equals in a mathematical sense, it's an assignment operator, because what you can do is you can define a to be 7, for example, and then you can say a equals a plus 3. Now, if you had this equation in a mathematical sense, a definitely cannot equal a plus 3, right? So in this sense, equals is not an equality operator, it's an assignment operator. But you can do that in Python. You can update the value of a variable by taking the previous value of that variable. So here we would expect this to give us 10. Now that's just covered some basic variable assignment and printing syntax. It can be very obvious to start with, but it's also good to get that terminology down, I think. Now, a lot of the time when we're writing code, we might want to add some commentary to our code, and that can be quite highly encouraged. This helps other developers understand our code. It helps us remember what we did previously. You might be working on a project, you might come back to it later on and not know what you've did. It definitely happens to all of us. So comments can actually help us out. Now, comments are lines in the code which are actually ignored by the interpreter, so they don't actually get executed or anything like that. And comments are quite simple to add. You just start with the hash key, and then you can type whatever you want. So here we are assigning some, let me spell that right, some variables. A equals 5, B equals 10, and then we're going to print these variables. So we're going to print out A and B. And if we run that, we just get 5 and 10, just as we did up earlier. Now, one thing about code comments, you don't want to comment every line. You really don't even need to comment in this style. I'm just doing this to demonstrate, really. And a lot of comments might be added just to make things explicit. But once you're down with the basics of Python, you definitely don't need to comment print functions saying that this is printing something. It's obvious from the actual method that's being called here that something is being printed. It's obvious here that something is being assigned, so we really don't necessarily need comments telling us that. Comments are more useful when there's a complex block of code that isn't immediately obvious. If someone has to spend some time figuring out what it's actually doing, then commentary can definitely help. Now that we've executed some cells previously where we've actually defined A and B are now stored by the interpreter. So they're actually available to us until they're deleted. So if I, in another cell, now do print A, I'm going to get access to 5 again because A has been defined in a previous cell. So I guess that's one maybe not immediately obvious thing about Jupyter Notebooks, is that any variables you define in one cell are still available in another cell. If you define a function in one cell, you can call it in another cell quite easily. So now we're going to look at modules, which is just going to be the last bit that covers our introduction. We're going to see in this course that we import libraries or modules into our notebook. So this allows us to extend the functionality of the basic Python. So people in the past may have written some code that simplifies a task so that you don't essentially have to reinvent the wheel. To import something, the syntax is actually quite straightforward. You just type import and you see that it becomes green because it's a keyword in Python. And then you can just type the name of the library. So for example, one of the built-in libraries in Python is called random. So I'm going to import random like that. And then we can use random. We can use functions from it. So I'm actually going to print something by running a function that's available in random. And to do that, I'm going to do random dot. That allows us to access a lot of the methods that are available as part of the random module. And I'm going to use the randint method. Now the randint method takes 2 numbers and those numbers define the range. So randint generates a random number between 2 values A and B, which you provide. So I'm going to provide 1 and 10. This is now going to give me a random number between 1 and 10. So if I run that, I got 10. And if I run it again, I get 3, and so on and so forth. Don't worry necessarily too much about what's happening here. We're passing these numbers, which are arguments, into a function. We're definitely going to come back to functions later, but I just wanted to add this into the introduction so that you're aware of what we're doing when we're actually running these import statements. So that's the end of chapter 1. Now we're going to go on to operators. So in this chapter, we're going to start looking at operators. We've seen some basic syntax of Python, how to print things, how to assign variables, and how to add code commentary as well, so that we can understand and document our code essentially. Now we're going to look at performing some basic computations, and this is often done through operators. Now, say for example you have 5 plus 10, right? 5 and 10 in this case are referred to as the operands, and the plus is essentially the operator. So you're performing this operation, which is 5 plus 10. You've got the operands, which are sort of the input to that operation, and then the plus or the minus, which would be the operator. Operators can actually do different things. So with numbers, they would obviously work as you would expect. If you do 5 plus 10, you're obviously going to get 15. But you can also add lists together. You can add other objects together, and they can do different things, and we'll definitely cover that shortly. Now, there are different types of operators. The most basic ones are arithmetic operators, and they allow you to do normal mathematical operations. The most common arithmetic operators we're going to look at in this code cell here. Now, one thing to note before we just quickly start with this is we can store the result of our operation in a variable, or we can directly print the output. So let's start by defining some operands. A equals 5, B equals 10. Now, if I want to now add these together, I can do A plus B, and that will add them together. I can assign that to another variable called C. Alternatively, I know that this is going to give me 15, and if I just want to see that, I can do print A plus B, rather than just printing A or B. So now this will give me the 15, but alternatively, like we mentioned earlier, we can assign this to a different variable altogether and just print that variable instead, and we'll get the same result. I'm just going to stick to printing things directly so we can look at the different operations. We have addition, we have subtraction if you want to do B minus A. Multiplication would be done as follows, and division is done as follows. There's also another arithmetic operator called modulus, which actually gives you the remainder. So I'm just going to put B percent A here. So percent is the modulus operator. Finally, there's the exponent operator, which we're going to cover here. This is basically a to the power of b, so 5 to the power of 10. So what happens if we run this? We're going to get various numbers. We've got our 5 plus 10, we've got our 10 minus 5, which gives us the 5. 5 times 10 is 15, 5 divided by 10 is 0.5. Now this is the modulus operator, which remember gives us the remainder. So 5 goes into 10 twice perfectly, and then there's no remainder. So this is just going to give us 0. And then finally, I'm going to assume that this is 5 to the power of 10. Now it's also important to use parentheses in more complex operations. Say I define a new variable 15. I can do print a plus b times c. Now if you think back to order of operations in maths at school, you'll know that we do the multiplication first and then we add on the a afterwards. So what's that going to give us? The b times c is 150. Add the a, that should give us 155. Now instead we might want to evaluate a plus b first, so we would put parentheses here and then multiply by the other value, and that should give us 225. If I run that, we're going to get the 225. Now there's a slight note here, and that is that operators behave differently depending on the types of the operands. I touched on this a bit earlier. You know, we can add integers together like we're doing here, we can add numbers together, and they work as you would expect, right? But then if you have strings, you can actually add strings together, which are essentially pieces of text, and that joins the text together. It concatenates it. So how is it that the plus operator behaves differently depending on what the operands are, like whether they're numbers or whether they're letters, for example, or lists, collections of letters and numbers? The mechanism that actually allows this to happen is something called operator overloading. So what we can do is we can actually, just for experimental purposes here, we can look at how addition is done in a slightly different way. I'm going to define two variables here, y equals 7 and z equals 6. Now, normally, obviously, you've seen by now, if we want to add those together, we would just do y plus z. We can print that output, store it in a variable, etc. And that gives us the 13. Now, what I want you to pick up on here, and it's not super important, especially if you're a beginner Python developer, but it's something that's important to appreciate, I think. What we're actually doing under the hood is we're taking our y value and we're calling a method on this. We're calling the add method, essentially. And you might have seen this when we were talking about imports earlier, but if we want to access methods or properties of an object, then we use dot notation. So we can access things that are associated with this y variable by hitting the dot. One of these things that's associated with the integer object is the add function. So we can do y dot underscore underscore add, and this is a method, basically. It's a function. So from y, we're calling this add method, and we're going to pass it the other operand. We're going to pass z. Now that also gives us 13. Now, you're never going to add things together by using this syntax. In fact, the reason why these underscores are in the method is because it's supposed to be a hidden method. It's not supposed to be technically accessible. But it's just interesting to see that what we're really doing when we're using this plus operator is we're actually taking our first object, running a method off of it, and passing the second operand as an argument. So what we can do with other objects that aren't necessarily integers is we can remap this. We can say, okay, here plus is performing an add, right? Well, instead, maybe with strings, plus is going to do a join. It's going to concatenate the strings together, for example. So there's a mechanism that actually allows us to do that, which is quite useful when we're defining our own types of objects. But obviously here, with the built-in Python objects like integers, strings, things like that, we're going to see that they are overloaded already, and the plus behaves differently depending on what the actual operands are. Just something interesting I thought I would add here. So next we're going to start looking at comparison operators. These differ from arithmetic operators. They're quite useful because in subsequent sections, we're going to create programs that make decisions, like it checks whether a certain condition is true or not, for example. Is this number bigger than this number? Is this number the same as this number? So these are our comparison operators. So again, to start with, I'm going to define some operands, which we're going to be using. Let's define 5, 10, and 15 as A, B, and C respectively. So one operator we can use is the equality operator. So I'm just going to print the result of this directly. And the syntax for this is A equals B. So this is the equality operator. It differs from the assignment operator because of the fact that there's two equal signs. So what this is actually going to give us is a Boolean output, a true or a false. And we're going to come back to that in a bit more detail shortly. These are integers. So we can look at a bunch of different types of objects in Python, like strings and lists and so on. And another one of these is the Boolean. And this operator actually returns a Boolean. So if we want inequality, another one is if we want, for example, let's use C this time. C does not equal B is with this exclamation mark syntax. Now, what if we want to look at values being greater than or less than? Well, it's as you would expect. There's a greater than operator and a less than operator. Finally, just to add on, we may also want equal to or greater than, like this, or equal to or less than, like this. Let's do A plus B here, for example. So we can combine operators here. We can say I want to add A and B together and see if that is equal to or greater than C in this case. It's always good to wrap things in parentheses just in case you don't do something weird like checking if C is less than A and then adding B to that. It would probably work without, but just to be safe. So let's run that, and we get a bunch of output here, false and true, which corresponds to all these conditions, which you can check if you like. But these false and trues are the Booleans we were talking about. These aren't numbers like we were seeing earlier up here. These are a different type of object altogether. So now we're going to look at the next little subsection, which are logical operators. Now, logical operators are actually useful when it comes to Booleans, like we just looked at. It allows us to take these true and false values and combine them to create one new output. Once again, I'm going to define some variables. I'm going to define A equals 5, B equals 10, and C equals 15. Now, this thing I mentioned earlier about using parentheses to sensibly group the different operands together is going to be particularly useful here. So there are three different types of logical operators we're going to cover here: and, or, and not. So and is true if both the operands evaluate to true, or is true if at least one of the operands is true, and not is quite simple, it just flips it. So if you've got a false and you do not false, that becomes true, and that is a unique one in the sense that it only takes one operand. So we're going to see these in action. I'm going to start printing something, and I'm going to use the AND operator. So I'm actually going to open another set of parentheses so that we can group things together. We're going to do print A plus B equals C. So you've already seen the arithmetic and the comparison operators, so you know what this is going to give us. A plus B is going to evaluate to 15, C is 15, so that's going to give us true. Now I'm going to use this AND keyword, and I'm going to have my second operand to the AND operator here. So let's do another condition here. Let's see if A times 2 is equal to B, which it should be because 5 times 2 is 10. So here we know that this is true, and we know that this is true. So true and true, remember, the AND operator evaluates to true if both the operands are true. If I just run that quickly, that is going to give us true, which is what we expect. I just want to quickly add here, there's an alternative to the AND syntax here. Instead of using this keyword, we can also use the ampersand, and that'll give us the same output. Now the OR operator, let's do something similar. Let's start printing A plus B equals C as before. This time I'm going to use OR, and I'm going to change the previous condition slightly and do A times 3 equals B. Now we saw that A times 2 was equal to B, but A times 3 certainly isn't. Now, if I run that, that also gives me true, simply because of the fact that with OR, only one of them needs to be true. So is this or this true? And the answer is yes. Now, similarly, as with the AND operator, there is a different syntax for this as well. So here we had the ampersand, instead of the AND keyword. Now instead of the OR keyword, we can use the pipe. That one, sorry. That little pipe is also used as the OR condition. Finally, NOT is quite easy. This one simply takes one operand on the right hand side typically. So we can do something like NOT A equals B, for example. So A equals B, we know that that is false, but we're doing not false. So that should flip the operand and give us a true. So all of these evaluate to true in this case. But play around with this, change some of these conditions. Note that if I now change this to something random like this, it should give us false because both of these are false now. Okay? Now that concludes our operators section. And we're going to come back to this because we're going to see different operators, especially when we look at the different types of objects that are available in Python. But now we're going to look at a certain type of object in more detail. We're going to look at numbers in a bit more detail, even though we have seen some numbers already. We're going to look at some different types of numbers in the next section. So welcome back to the Python tutorial, and here we're looking at numbers. We've looked at performing operations using integers, which are whole numbers. However, there's a bunch of other numerical types that we can use, and types is a key word in Python. It refers to what kind of object we are dealing with. So one particular type we've seen already is the Boolean, another one is the integer, and we're going to see some more types shortly. If you want to see what the type of an object in Python is, you can use the built-in type function like this. So you can pass in a variable that we've defined, or you can just give it a variable directly like this. So if I do type 5, it tells me that it's an int. If I do type false like this, it's going to tell me it's a Boolean. Now, one particular type I want to start talking about now is the float. There's a lot of other numerical types as well as integers. Because here we've only been using whole numbers. Now here we're going to start looking at floats, which are actually going to allow us to use decimal numbers or fractions. Now, one nice thing about Python is that whenever you instantiate an object in Python, the interpreter in the background automatically infers the type. So the nice way of saying that essentially is you don't have to say when defining a variable, like in some languages, you don't have to say that this is an int a equals 5, for example. You can just do a equals 5 and Python knows that this is an integer. So if I do type again and I give it 5.5, so it's not a whole number anymore, what's Python going to interpret this as? It's going to say that it's a float, so it's inferred it as a float. So this is the next data type we're going to be using. Decimals or fractions can be represented using the float data type. So the float comes from the fact that the decimal point can essentially float. It can have a variable number of digits before and after the decimal point. Now, a lot of the operations you saw before, like the arithmetic operations and the comparison ones, we can also perform them on floating point numbers, and they typically work in a similar way. So for example, if I do print 5.5 plus 4.5, I'm going to get 10.0. Note that I don't get 10, I get 10.0 specifically. So this gives us a bit of a clue that this is a floating point number, it's not a whole number. Now, before moving on to mathematical functions, I just wanted to add a little note here. Floating point numbers are stored as decimals in memory. Now, for reasons that are somewhat beyond the scope of this course, they don't necessarily have infinite precision. Operations on floating point numbers can introduce something called floating point error, and feel free to research more into that. But you can demonstrate this in Python. If I type 1 minus 0.9 minus 0.1, here I'm subtracting a few floating point numbers from this. What am I going to get? You would obviously expect to see 0, but we see this number. It's a very small number. This e minus 17 is basically saying it's 10 to the power of minus 17. So it's a very, very small number, but it's not 0. It has a slight difference. So it's important to be aware of this, especially when you're using comparison operators, because if you now try doing something like this, it's going to give you false, whereas you'd expect that to be true, right? It's important to be aware of that. There are ways around it. You can check if this number is greater than a very, very, very small number, for example. But please feel free to look into the reasons as to why this might be. Finally, we can actually convert integers to floating point numbers and vice versa. We can do this by using the built-in functions that allow us to convert between different types. So say I want to convert the number 5, which is a whole number here, to a floating point number. If I run that, I get 5.0. And remember, that 0.0 tells us that this is a floating point number. Now, you have to be careful if you're doing this in reverse. If you do int, for example, and you pass it 5.75, let's say. If I run that, it's just going to give me a whole number. And in this case, it's 5. It doesn't necessarily work like where it rounds the number for you. So this isn't going to give you 6. Instead, what it's going to do is it's just going to drop the floating part. And you're just going to be left with the whole number component. Now we're going to start looking at some mathematical functions. Python includes a number of built-in mathematical functions, and we can import these. Some of these are actually just available directly, others we do need to import the built-in math library for. Now, these aren't necessarily going to be all the operations that you can do, and also I don't want you to necessarily memorize all the different operations and how they work, because as long as you have a good grasp of what's available generally, a good programmer is then able to search on Google, on Stack Overflow, for whatever functions they require, and they're able to then incorporate that into their program. But let's start looking at some of these operations. So I'm going to import math. Remember, we looked at imports briefly before. Now, I'm going to define some variables so that we can work with them. Let's go a equals 5 and b equals minus 10. So now one of the functions that's available is an absolute value function. So I can print the output of this function. So what function are we going to use? It's called abs, like this. Now that will give us the absolute value of any number we give it. So we know that this is minus 10, but if I print that, it's going to give us the absolute value, the magnitude, which is 10. Now we're going to look at a function that actually comes from this math library. So this abs one actually comes built into Python. We don't even need to call it from any particular place. But now let's start using one of the functions that comes from the math library. So in order to use these functions, we type the name of the library and then we press dot. Now this dot syntax is what allows us to access the functions that are available in this math module. Now, one cool thing to note here is if you do type math and dot, if you now hit the tab key, you can see all the functions that are actually available in that library. So you might be able to use this to quickly get what you need. Like if you needed the value of pi, for example, you might be using that. Here we're going to use sqrt, square root. So I want to square root a, and we'll see the output of that in a second. We can also do something like math.exp, which is the exponential. Let's do that of a. Let's also print some trigonometric functions. So sine a, cosine a, and the tangent of a. Oops. So we can see the output of all these different functions, but you also saw that when you hit tab on the math module, there's a lot of different ones that are available. We even saw we can get the value of pi from there, but this just kind of shows you how you would actually use some of these methods. So finally, we may also want some random numbers, and so for that we can use the built-in random library. For example, we may want to create a game, or we may want to plot some random numbers against each other. So in order to do that, we're going to import the random library. Now, just like before, we can access functions from the random library using this dot syntax. One of those functions is just random. Now, this will actually just give you a random number between 0 and 1. If I keep running it, you'll see it gives me that random number. There's also random.uniform. Now, this will generate you a random number between two values. I'm going to give it 10 and 20. So this is a function that expects two arguments, which are your start point and your end point. We'll look at functions and arguments in a bit more detail, but just to show you quickly here how you might generate these random numbers. Now finally, there's another one I want you to look at called randint. This generates a random integer between two values. So I'm going to give it 1 and 5. So here we can see this gave us our random number between 0 and 1. Then we got our random number between 10 and 20, but that's a float. Randint is what gives us the random number between 1 and 5 in this case. Now, just before we move on to the next topic, it's also useful to be able to rename libraries. This helps us shorten the name, just in case if a library has a particularly long name, we can shorten it in case we're referring to it multiple times over and over again. You might see a lot of this, and there's a lot of convention in terms of how these are named. For example, when you're working with data and you're using pandas, pandas is often shortened to PD. NumPy is often shortened to NP, but we don't even have those installed. We're not going to be working with those in this tutorial. We may, for example, import random as. Now we can rename it whatever we want, anything crazy, but obviously it's better to be short. I'm going to call this bright yellow duck just to demonstrate you really can call it whatever you like. Now that we've imported it as bright yellow duck, we can actually just do bright yellow duck .random. Just like we had random.random here. So by default, it will just name it as to whatever it's imported as. But here we've renamed it. So that concludes this section on numbers. So now we're going to look at another data type in Python called the string. Hi and welcome to the next part of this tutorial, which is on strings. So we've just looked at numbers in detail and the different types of numbers that are available, such as integers and floats. And we've also looked at booleans briefly. Another very commonly used data type in Python is the string. So we can create variables that hold words or sentences, but they can also contain numerical values. They are just of a different type. Now, strings can actually be defined using single or double quotes. However, we're going to use double quotes here. It's particularly important because sometimes you might want a quotation mark inside a string, and that's where double quotes are quite useful. So I'm going to define a new variable called introduction. And if we enclose this in our quotes, then we're going to define this as a string. So I'm just going to call this hello, I am 31 characters long. Please feel free to check that for me. But now if we print introduction, we are now going to get a string. And we can check the type of this string, remember, by using the type function. And it is of type str. Now, strings can be manipulated using different methods, and they can also be manipulated using operators. Remember, we had that little discussion earlier where operators and methods are essentially doing the same thing. And we're going to look at a lot of these shortly. However, just as a quick introduction, let's look at what the addition operator actually does. The addition operator concatenates strings together. So it adds numbers together, but it actually concatenates strings together. So what does that look like? Well, let's define two different string variables. So let's go with string part1, and what should we call this? Let's say I am broken, please put, and then let's define a part2. Me back together. So we've got this string which is broken into a couple of different pieces. So now if I create a complete string, I want to add these together using our addition operator. And remember, these variables I'm putting in are the operands to this operator. So string part2. And I could have just printed that directly, but I've defined it as another variable. So let's see what happens when we print that variable. We get the complete string. So now it's been put together. So now you can see that this plus operator behaves differently depending on the types of the operands. Note that the operands must be of the same type. If we're introducing numerical values, we first need to actually convert them to a string. So I'm going to define a string here, which is the text component. Let's say here are tomorrow's lottery numbers. Now, let's define what those numbers are going to be, 1, 2, 3, 4, 5, for example. And now what we need to do, if we actually want to concatenate this together, we've got string text plus values. Now we've actually got a string here and a number here. If we run this, we'll see that Python is not going to like it. It tells you that it can only concatenate strings, not integers, to strings. So it's telling you that it expects this other operand to be a string. So how can we deal with that? Well, we can just do str, that number, and that will convert it to a string. And there we go, we've printed that complete string. So before we move on to the next little subsection, we're going to look at the multiplication operator as well, which can be used to repeat a string multiple times. So we saw previously that if the operands are integers, it just multiplies the numbers together as you would expect, but it can also be used to repeat a string multiple times. So in order to demonstrate this, let's define a solitary elephant. Now we're going to give him some friends, and the way we're going to do that is we're going to do herd of elephants equals, we're going to take that solitary elephant, and now we're going to use that multiplication operator. So this actually duplicates that string and essentially concatenates all of those duplicates together. So if we just print that herd of elephants, we see that that string has now repeated multiple times. So now we're going to look at the next little subsection, which is membership. Now, membership will be useful when we look at collections. So when we look at lists of objects, for example, we can see if one particular number is in a list of other numbers, for example. Membership can also test if a character is inside a string or if a substring is inside another larger substring. And this will work the same way when we look at collections. But let's introduce it here. So I'm going to type a main string, which is I contain a very secret message. Now, our substring, what's that going to be? I'm going to call it secret message. Now, what we can do is we can see if this substring is inside this main string by using the membership operator, which is not something we've looked at yet. And it's quite a straightforward one. All I have to do is use the in operator. So I'm going to do substring in main string. So the two operands are our strings, and then the in basically tests if this is inside here, and it gives you a boolean. Now, if I check for something else like elephant, since we're on that theme for some reason, in main string, that's going to give us a false, right? Now, you might want to do the opposite case. You might want to see if elephant is not in there. You can do this in two ways, actually. You can do print elephant not in main string, because not in is actually an operator in its own right. But you can also do something like this. You can do not and use our not operator, which, remember, just flips a boolean. Now I'm going to give this just one operand, which is the rest of the operation here. Elephant in main string. That should give us true both times because elephant is not in the main string. I just wanted to illustrate that this syntax is somewhat flexible, simply because of the fact that this is an operator in its own right, whereas here we're using the in operator but then just negating it. So there's a bit of a difference there. Now we're going to look at slicing. This is also going to be useful when we look at collections, lists of numbers or strings, for example. And it allows us to take specific elements from a list or specific characters from a string. And there's two different types of operators here. There's the slice and then there's the range slice. So the regular slice allows us to take just one character from a string or one element from a list. And the range slice allows us to extract multiple. You basically give it a start point and an end point to slice that string. Now, one important thing to cover here is that Python uses something called zero-based indexing. The first element of a list, or the first character of a string, for example, is always the 0th element. I like to think of it as the distance you have to travel from the first element to get to your chosen element. So if I want the first element, that's distance 0. If I want the second element, I have to travel 1 unit to the right, so my index is 1. You'll get used to this over time, and it's one of these things that's a bit easier demonstrated. So let's start using this slice operator. So how do we do it? I'm going to define our big string, which is I am an elephant. I promise we'll move off this theme very shortly, but I'm just going to demonstrate to you here. If I give it big string, now this is the slice operator. Okay, we open these square brackets, and here we can pass our single slice or our range. For now, I'm just going to pass this single slice of 0, and I'm actually just going to duplicate this line here just to show you what it actually looks like when we slice different elements. So when we do that, this makes it quite immediately obvious that 0 is that first element. The space is then the first element essentially. And then at index 2, we have the A. At index 3, we have the M. So that's something you might have to just get used to. But just bear in mind that it always just starts at 0. So now, what if we wanted to extract an entire word from the string, for example? We can do that using the range slice operator. Now, this operator is a bit of a funny one in the sense that the first value that you provide it is the element from which we start slicing, but that value is inclusive. The second value is the element that we end at, but that is exclusive, okay? It's just how the slice operator works in a lot of languages. So if we want to slice up to the 10th index, we know that slicing will go up to but excluding the 10th index. And this is one of those things that's better demonstrated. Let's redefine our string down here. And what we know is that, let's say, for example, we want the word elephant. The first character of that is, let's count along, 0, 1, 2, 3, 4, 5, 6, 7, and 8. This is the 8th one. And then the last character of this is at index 15, okay? So what I'm actually going to do is I'm going to print big string, and I'm going to use that range slice notation. So we give our start point, our colon, and our end point. Now, I don't want to just give it 15. Even though that the elephant starts at 8 and ends at 15, if I run this, I'll actually get elephant. So this is what I mean in terms of the first number that we provide being inclusive, but then that second index we provide is exclusive. So if we want to go up to but excluding the 16th index, we have to pass 16 here. So that's just a little thing to note. It's not a big deal if you don't necessarily remember this, because when you do it in practice, you'll go along, you'll type your numbers in, you'll see it's a bit wrong, so then you'll just adjust it, right? It's not a big deal, but just bear in mind this zero-based indexing, and bear in mind this exclusive range operator here. Now, sometimes we actually want to slice all the way to the end of a string, or all the way from the start of a string. So all we have to do is omit the index that we want to continue indefinitely, essentially. So if I do big string again, I'm going to do 5 colon. I'm not going to supply an endpoint. And similarly here, I'm going to do the same thing. I'm not going to supply a start point. I'm just going to say go up to 4. And then it spits out an elephant, I am. So we're talking like Yoda here or something, but it clearly demonstrates to you that we don't necessarily need to know the length of the string if we want to go all the way to the end, for example. You don't have to figure out for yourself that you have to put 17 here, for example. Finally, sometimes we want to index from the end of the string instead of the start. Python actually supports this by allowing you to provide negative indices. Now, bear in mind these aren't based off 0, so it does work slightly differently. But if I pass my big string again and I give it -1, that actually gives me the last character of this string, which is the full stop. If I give it -2, it should give me that T. So you can actually go backwards the other way. Feel free to experiment with that. Now I want to talk about formatting with you. Sometimes we want to create a very long string. And this is where multi-line strings are actually quite useful for this. One thing to note is that if you start new lines in your string, they're also going to get rendered as new lines by the print function. So let's have a look at that in practice. So let's say very long string equals. So if you want multi-line strings, remember we use triple quotes. So I'm going to start by saying this is a string, and let's create a new line that is very long and spans across multiple lines. Now let's print this very long string. It's not very long, but it's longer than what we've seen so far. So you can see that it also renders those new lines. That's important to note. Now, new lines can actually be added in a string manually as well, using what we call an escape character. There's actually quite a few different escape characters if you want to add tabs and things like that, or if there are special characters that you need to actually show up in the string which otherwise do unusual things. Maybe we'll come back to that soon, but this first escape character I want to show you. Let's start defining this string. Multi-line string equals this string. Now \n is the character we're going to use, has multiple lines, and we're going to print that. Now you'll see that it has created those multiple lines. Like I said, there's a lot of different types of special characters we can use to do some formatting with our string. You'll notice that there's a little indent here. That's because there's a space after the \n. If you remove that little space, then it will render accordingly. It looks a little weird here, the fact that that \n is right next to the has. So bear that in mind. I'm just going to leave it like that for now. So now we might often want to create a string from multiple different variables. So we've seen before we can use operands and type conversions to actually construct our string. So let's start by creating our string. Part1 equals, and this you should hopefully be familiar with by now. Hello, I am an elephant called, let's call him Liam, and I am, and I'm going to define an age. Let's call that 26, and then let's create our string part2. We know that this is going to be years old. Now we've seen how to combine strings before, right? We know that we have to concatenate them by using the addition operator. We're also going to have to be careful with this number 26. We're going to have to convert that to a string first. So let's see what let's see how we do this here. Combined string equals string part1 plus. Now I also want a space between the age and the different pieces of the string here. So I'm going to add that in manually like this with a space. Let's add the string 26 here. Let's add another space. And then finally, let's add the second part of our string. Finally, let's have a look at what that looks like. This has been a bit of a waffle. It's been a bit cumbersome, but we have arrived at the right answer. Hello, I'm an elephant called Liam, and I'm 26 years old. Spacing is there, the age is there, but we've had to do a type conversion. We've had to add spaces in manually. There is an alternative syntax that we can use, and it's something I'm going to make use of here. And this is f-string syntax. It allows us to quickly insert variables into strings. There are other ways of doing this, but this is something that I find quite quick and efficient. So let's create a variable, which again gives us our age. I'm actually going to create our f-string directly here. So let's just call it an f-string. To create an f-string, we start with the letter f and then we open our quotes. So how does an f-string work? We start typing our string as normal. Hello, I am an elephant called Liam, and I am. Now, to insert variables, all we have to do is open these curly braces. And in here, we can insert any variables we want. We can insert them directly like this. We can do operations here like this, or we can just reference a variable we've defined before, like age, years old. Now, if I print this, you'll see I get the output that I want. The benefit of this is, note that we have not had to actually do an explicit type conversion here. We've not had to convert this to a string. We've just inserted that directly into this S string. We haven't had to worry about concatenating things. That's just a useful method, I find. Now, many functions are actually available in Python for us to manipulate strings. And as we saw with some of the mathematical functions, there are a lot available, and a good programmer is able to just research specifically for what they need to do. But we're going to cover a few here. Now, a lot of these methods can actually be called directly from the string itself. And this is a feature of object-oriented programming, which is beyond the scope of this course. But there are methods associated with objects, such as strings. You saw before when we were doing mathematical functions that we imported the math library, for example, and we passed our numbers to those functions. Well, sometimes we can actually use methods that are associated directly with the object. So, for example, if I define a string, let's stick with the animal theme, but I'm sure you're getting tired of elephants. Let's go with camel. Now, if I want to capitalize the first letter of that string, for example, let's do print string underscore lower dot. Similarly to how we were accessing methods from modules using dot syntax, we can access methods from an object, in this case a string object, using dot syntax. If we hit tab, we can actually see what's available. I'm going to use capitalize. And if I run this, it's actually going to capitalize the first letter of my word for me. Now, many of these methods are available, as we've mentioned. One thing I want to slightly touch on here is the fact that these methods all return a new modified string. So you can assign them to a new variable or print it directly. Now, the existing string is not actually modified, and this is because strings in Python are immutable, like other objects such as integers. Some Python objects, when we come to them, like lists, are mutable. That means they can be changed after they've been defined. Let's try have a look at what that means in practice here by looking at a few methods. Let's define a string. String base equals hello, I am a string. Now, if I want to make this uppercase and lowercase, let's have a look at string base dot upper and string base dot lower. Now, what I was mentioning here is that when you run string base dot upper, this is giving you a new string that we can print. Because if I now print string base again, you'll see that that is exactly as it was originally defined. It's got no capitalization. So we can see that it actually gives us a new string. It doesn't modify the existing string. Another useful method is if we want to find something within a string. So string base dot find. Let's find a substring in here. Let's find string. So we are looking for this word. This find method will actually give us the index at which that is found. So it starts at 14. This should be the 14th index. There's a lot of other useful methods. Let's look at string base dot ends with, for example. Does it end with string like this? It does. So that's a useful way of testing the end of a string. Another useful method that we might use is the len function. Now, the len function is a general function. It's not tied to the string object because you can actually get the length of lists, of tuples, things like that. So we can also use this len function on our string here. That's how we would get the length of a string, and it's 21 characters long. Finally, one other useful method is this. If I do string base dot replace, I'm going to replace string with donkey. So this replace function here takes two arguments. It takes the thing you actually want to replace in the string and the item that you actually want it to be replaced with. If I print that, that's going to tell you, hello, I am a donkey. So we've seen a little bit how to manipulate strings here. There's a lot of different other methods that are available, but this kind of gives you a flavor of how you might actually access them and some of the different manipulations that are available to you. Next, we're going to look at collections. Hi, and welcome to this next chapter on collections. So Python includes various data types that are actually collections of some of the other objects that we've seen. The most common example is lists. So we've seen that we've had strings and numbers, but we can actually have lists of these strings and numbers. So we're actually going to cover the following types of collections here. We're going to look at lists, tuples, sets, and dictionaries, and they have their similarities and differences. Now, these collections are built in, and there are others, but these are the most common ones that you're going to find. And to start with, we're going to look at lists. Now, a list in Python is very versatile. It can store objects of different types. So we can have strings, integers, booleans, all that kind of stuff. In fact, if a user defines their own type of object, their own class, these can also be put into the list. Now, unlike some of the other objects we've seen so far, lists are actually mutable. So they can be changed after they've been defined. Now, in order to define a list, it's actually quite simple. So I'm going to start by defining a list of animals, of course. So we're going to go with an elephant, a camel, and a tortoise. Now, this is the syntax. You just have the square brackets and you provide an item one by one separated by commas. So there's a list of strings. You could have a list of numbers as well. Such as 1, 1, 2, 3, 5. But we can also have a mixed list. So the advantages of lists in Python is that you can have a giraffe followed by 75.0. So we can have floats. We can have a hippo, a walrus, and then an integer such as 10. So we can mix different types. Now, accessing different elements of a list is done using slice notation, and it works in exactly the same way as it does for strings, as we saw earlier. So if we do print list of animals and we give it the first element, which is the 0th index, we should get elephant from that. And let's say print list of numbers, and here we're going to do a range notation. So we're going to do 2 to 4. So what does this mean again? So we go from the second index, which is the third element, so it's this, and we go up to, but excluding the fourth one. So we should just see the 2 and the 3. If I run that, that's what we see. Now we can actually modify items in a list by just using the assignment operator once we've sliced it. So for example, let's redefine that list of animals. We don't need to, but I'm just going to type it again here. And list of animals 0. So we know that gives us elephant, right? So now what if I change this to no longer an elephant? Now if I print the list, you can see that the element has changed. Now, lists have various methods associated with them, just like strings. And quite a common one is an append method. So we can use this to add items to the end of a list. This is very common. We're going to see it when we look at loops. We build up lists by appending things to them one at a time. And just a quick note here that lists, as we mentioned before, are mutable. So when we actually use the append method, it doesn't actually return anything. It just modifies the original list. So we'll see that in just a moment, because what we're going to do is we're going to try append to this list here. We're going to do original list equals, let's say 10 and 20. And we're going to use this method. So remember, this is a method that's associated with list objects. So we've got a list object and we're going to call the append method on it. Now with append, we can append anything we want. I'm going to add 30 to this list, but note that I'm not assigning this. I'm not saying new list equals original list or append. Here I'm just modifying the original list. The actual return type of this function is nothing. If you printed the output of this, it won't give you anything. So what you actually need to do here is print the actual original list. So we've seen before in the past that it doesn't work that way with things like integers and strings, and that's because those are immutable, whereas lists are actually mutable. We can modify them. Now, similarly as we've seen with strings, various operators have been overloaded for lists to make working with them easier. And as with strings, we can concatenate lists using the addition operator. We've also seen that membership operator before. Remember when we were looking at substrings to see if they were inside another string? Let's demonstrate both of these here. So I'm going to define two lists, 1, 2, 3, and b equals 4, 5, 6. Now if I do print a plus b, we see that it actually creates a new list. This new list is a concatenation of the existing two lists. So it works just like string concatenation, really. Let's now do print 1 in A and print 4 in A. So we can actually use membership operators to see, is 1 in A? Yes, it is. Is 4 in A? No, it's not. Finally, Python includes some built-in functions and list methods. So we're going to go through a few of these here. Let's start by defining some lists. Let's go 1, 2, 3. Let's mix this one up a little bit. Let's go 8, 7, 4, and 5. I'm going to define a list of strings as well, actually. So let's do polar bear, whale, hippo. I don't think we've had any of them yet. Let's now get the length of a list. So we've seen already the len function. It's like this. You can pass this a string and it'll give you the number of characters in that string. You can also pass it a list and it'll give you the number of elements. So that's a method that's not actually associated with any particular object. And another common function that's used with lists is max. So if I print the max of b, for example, and alternatively there's also the min function. So if I want the minimum of a, so these are just going to give me the lengths of the list, the maximum and the minimum value. If I actually print that just to start with, you start seeing 3, 8, and 1 down here. Another useful one is actually finding where an item is in a list. We had something similar with strings. With this, we can do c.index, which gives you the index of an item. The item I want to find is polar bear, and we expect to see 0 from that because it's the first element of that list. Now, finally, we can actually insert an item into a list. So what if we do c.insert? Now, insert actually takes 2 arguments. It takes a position, so an index where you actually want this item to be, and it takes the item itself. Now, one thing to note is that the insert function, the insert method, does not actually return a list. It simply modifies the original list, similarly as with the append method. Now, so if I actually printed the output of this, if I print the output of this, you're actually not going to get anything because this method doesn't actually return anything. All it does is it modifies the existing list. So let's do c.insert. At position 2, I want to insert a sheep. And I'm going to print that list. Notice how I'm printing the exact same list as it's been defined here. It's just it's been modified in place. Let's print that. And we see that sheep has been added. It is now at index 2. 0, 1, and 2. Actually, one more method I want us to look at is the sort method. And again, this is another one of those that modifies the existing list object. So let's do b.sort and print b. So we saw that we defined this list that was in a jumbled order. If we run that sort method and then print it, we get 4, 5, 7, and 8. So one thing we will see later on is that lists are quite useful for iterating over. And we're going to see that when we actually come to look at loops and things like that. So we've covered the first type of collection here. So now we're going to move on to tuples. One thing to know is that once you understand lists, you start understanding a few of these automatically because they do share a lot of similar properties. So let's start looking at tuples. This section is thankfully quite short because, as I mentioned earlier, some of these collections do share similarities. Tuples are sequences like lists. The difference is that they're immutable. They cannot be changed after they've been defined. A lot of the methods that we saw earlier apply to tuples as well, and instantiating a tuple is quite simple. Instead of using square brackets, we're going to use the curly brackets. So let's do tuple of animals, of course. Let's start with chicken, cow, maybe a frog. So that's how we define our tuple. Now you can try some of the various operations we saw in the previous section and try and manipulate them in the same way, but what you will not be able to do is actually modify the existing tuple. If we try doing that and I say that I want the first animal to actually be a whale, it's not actually going to work. Tuple object does not support item assignment. So we can't do that, and we also can't append to the list. So now you might be asking yourself, if tuples are the same as lists, except we can't change them, why would we ever use tuples? Surely we can just use lists instead, and you know, if we want to modify it at some point, we can do. We have that option. And honestly, that is what we see in practice. Lists are very commonly used, more commonly used than tuples really. Some of the reasons we might want to use tuple are if you know your data is not going to change, then tuples could be considered faster. They have a fixed memory allocation, and that brings with it some efficiency advantages. It's not going to be particularly noticeable, especially when you're creating tuples of random animals, like 3 or 4 of them. But if you are operating in, you know, a big complicated program and it's a function that's used over and over and over again, that cumulative time save could be helpful if it turns out to be faster. Also, one other slight benefit is that we know that tuples cannot have their contents changed. So it essentially acts as a form of protection. You might create a tuple of values that you know cannot change. You might just have a tuple of some constants, maybe some scientific constants, for example, that you need in your equations, and you know that they're not going to change. So it essentially acts as that form of protection, really. So now we're going to look at sets. Sets share some similarities with lists, and they are mutable, so they can be changed. However, they are unordered. You cannot access elements of a set by using an index. They have this special property that they must contain unique values. They're pretty much equivalent to sets in the mathematical sense. Now, we can instantiate a set by using curly braces instead. So let's say set of numbers equals 1, 5, and 9. Whoops. 1, 5, and 9. So we've instantiated this set. We can actually add values to this set by using the add method. But remember that this is another case where the original set is modified. It does not return a new set. So let's do set of numbers dot add 13 and print that set. Now we see this has 1, 13, 5 and 9. You'll also notice that the 13 seems to have appeared in a bit of a random place. Remember, sets are unordered, so the order doesn't actually necessarily mean anything. What if we try adding a number that already exists though? So set of numbers dot add 5. And if I now print this set, it doesn't throw an error, but it just gives you the exact same set. So they have this property that all the numbers can be unique. So that's going to be quite helpful in certain scenarios we might see shortly. Now, there are a few operators that we can also use on sets. We can add sets together and preserve the unique values after combination. And the actual operator that's used to do this is the pipe operator. We saw that it was previously used to perform an OR operation, but for sets it actually performs a union instead. Now there are actually methods on sets, just like the add method, that you can use to union sets together, but I just want to show you this pipe operator here. Let's do print. And rather than assigning the sets to variable, I'm just going to define them on the fly. Let's do 1, 2, and 3. And let's union that with 2, 3, and 4 and see what we get. We get 1, 2, 3, and 4. It's basically a union of the sets together, and the unique values that are left after that union are 1, 2, 3, and 4. Now we also have the subtraction operator and the intersection operator. I can quickly show you. If I do print 1, 2, 3 minus, if I find it, 2, 3, and 4, what does that give us? That gives us just 1, because the 2 and 3 from this set are subtracted with any matching elements from this set. Now, finally, that intersection operator I wanted to show you. If I do 1, 2, 3, and 1, 2, let's do 2, 3, and 4, that gives me 2 and 3. It finds me the intersection, the values that are common to both sets. So there's a few set operations that we can look at here. And as I mentioned earlier, they can also be called using methods. Now, one thing to note while we're here is that collections of different types can actually be transformed into each other. So we can actually take a list, convert it to a set, perform set operations, and then convert it back to a list if we absolutely need to. So let's start a little experiment here. So let's start by defining two lists, and we're going to try subtract one list from another. So I'm going to define my main list of animals, of course, and we're going to go with horse, elephant, whale, and tortoise. And now we're going to define our subtraction list. Let's go with horse, whale, and giraffe. So we actually want to take this list and subtract the elements that are in this list. So you can see we want horse to go, we want whale to go, so we would just be left with elephant and tortoise if we subtracted one list from another. So how would we do this step by step? Let's first convert them to sets. Main set equals set main list, and then let's go with subset equals set sub list. We can use the set function to convert a list to a set, just like we can use the list function to convert something to a list. Now let's subtract them. So let's get our output set equals main set minus that subset. And then finally, let's convert it back to a list. So we can do output list equals list output set. Let's see what that looks like. So just like that, we've taken one list, we've taken this other list that we want to subtract, we've converted them to sets, we've subtracted them, we've converted it back into a list, and then printed that. Now, as you start getting more proficient with Python, you can start doing these things all in one. Let's do that operation in one line. If I do print list set of the main list minus the set of the sub list, you should see we get the exact same thing. I've converted each list to a set, subtracted one from the other, converted it to a list, and then printed it all. Don't worry necessarily if you don't prefer doing it all in one line like that. Please feel free to be more explicit if you need to be. It's not generally better anyway to do everything on one line. Because you could argue that looking at this is a bit clearer, for example, and not just to new people, but whenever you're looking at someone else's code, it's always easy to read it if it is separated out into steps, rather than going, oh, we're converting this to a set, subtracting, you know. But that is definitely a subjective thing. So now we're going to look at dictionaries, the final type of collection. So dictionaries are actually a bit unique. They allow us to store and access values using keys instead of indices. So we saw with lists and tuples, we can access elements using the slice notation, using the index. But instead of passing the index, we can also pass keys to dictionaries instead. Now, keys can actually be anything. They can be numbers, just like indices before, but they can also be strings. Each key is actually separated from its corresponding value with this colon, and we're going to see the syntax in a second. Now, one thing to note is that keys must be unique. Just like indices in a list are unique, you go from 0 to the length of the list minus 1. Keys must be unique in a dictionary. So how do we define a dictionary? Let's go with a different kind of example here. I'm going to start defining my car. Now, we're going to create a key called brand. So what brand is my car? It's a Fiat. Now, we separate key values by using this colon notation. So what we're saying is that the brand is the key, and the value associated with the brand key is Fiat. And then we use a comma to get a new key value pair. So now I might want color. The color of my Fiat is black. And then finally we might want some technical specs for the car. I don't know, let's talk about displacement, for example. So how many liters is it? It is a 1.9. Let's store that as a float instead of a string, because you can mix and match values in a dictionary just like you can in a list. So that defines as a dictionary. Now, just one style point I think might help. You can actually lay out your dictionaries as follows, and it might make it a bit clearer. You'll see what I mean. If I do my car equals and open this brace and hit enter, we can start laying it out as follows. We can do brand Fiat, we can do color black, and displacement 1.9. Now this is a bit easier to see, so if you are creating dictionaries, I recommend laying it out like this because it's easier for the programmer to see. Now if we want to actually refer to these values, we can use slice notation, except as before, instead of passing integers, we actually pass the key. So I want to print my car color, and that will print black. Now adding to or modifying the dictionary is quite straightforward. I'm just going to redefine the dictionary here, although you don't necessarily need to. I'm going to create a new key by doing this. I'm going to refer to a key that doesn't exist yet, fuel, and then I'm going to set that to diesel like this. That will now, if I print that, that has now added a new key, which is diesel. Now you can also update an existing key as follows. You can do my car, you can reference the key, so let's go with brand, and let's have an upgrade. Let's change it to a Ferrari. Now if I print my car, again, you'll notice that the brand has actually changed. So that's how we can sort of manipulate these keys a little bit. There are some methods associated with dictionaries, and a couple of useful ones are going to be keys and values. These two methods will be useful when we want to iterate over the dictionary, so you'll see that later on. But now that I've got my dictionary, if I do print my car.keys as a method and also print the values, it'll give me these lists: the brand, the color, the displacement, the fuel, those are the keys, and the values associated with them are these. Now I can also print my car.items, which actually gives me these tuple pairs inside a list. So it will tell me that the brand is Ferrari, the color is black, etc. Now, one thing to note is that you might notice that the outputs of these aren't actually list. It's dict_keys and dict_values. Now, they aren't actually lists. They can be easily converted to a list if we want to, and we'll do that in just a second. But they are not actually lists. So a lot of the list methods we saw earlier might not work with these. However, what we call them is we refer to them as list-like. So they can be iterated over like regular lists, and we're going to see that later on. And we're going to see what iteration even means. But what we can do is we can convert them. So we can do print list my car.items. So we can use the list function to convert it directly to a list. So now this is a real list as opposed to dict_items, which is like a custom type of list. Now, you can still use these in iteration, so you often don't even need to convert it to a list, but we'll see that later on. So now we're going to move on to the next section, which will be about decision making. Hi everyone, and welcome to this next section called decision making. Sometimes we want our Python programs to be able to make decisions and perform different actions based on certain conditions. So if this is true, do something, otherwise do something else. There's no real limit to the number of different conditions we can test, and there are limitless numbers of scenarios in which we may want to do this. We may want to check if the speed of a vehicle is over a particular value. If it is, we may want to apply the brakes. If it's below a certain value, we may want to accelerate. Now, we've seen some of these conditions before, and the condition is provided as a Boolean, and that variable takes true or false as values. Now, we've seen before that we've used comparison operators to output a Boolean value, which is quite helpful for providing a condition to our decision maker. So for example, print 20 greater than 10, or print 5.0 equals 4.5, or print dog does not equal cat. That gives us true, false, and true. Now, we've also seen we can combine our Boolean conditions using logical operators. So we might want to do print 20, let's group these sensibly, print 2010, and 5 does not equal 4. That gives us true because both of these conditions are true. So now you might be able to imagine that we can combine these conditions to get this one value that says, okay, this is true, now let's execute our code. So we've done 20 greater than 10, which is true, and we've done 5 is not equal to 4, which is also true. So that is basically the same as doing print true and true. We've seen before that the AND operator works. If both of these are true, it returns a true. If I do false and true, it's going to give me a false. Now we can use these conditions to make decisions through the if statement. The if statement lets us test the condition, perform an action if that condition is true. Now that condition is supposed to be a true or a false, but remember we can combine multiple conditions using AND and OR operators to test multiple conditions. So we're going to see that in just a moment. So let's go with our example of a car. Car speed equals 40 and speed limit equals 30. First, let's create our test condition. If car speed is greater than speed limit, we want to do something. So this is the syntax here. This is our comparison operator, which allows us to compare these values, and this is going to output a Boolean variable. We know this is going to be true just by looking at the numbers, so we're basically doing if true. So you can think of this as if and then our condition, and then we provide this colon to start referring to the block. So now whatever's in this block here is going to get executed if that condition is true. What do we want to happen? I'm just going to print braking if we're above the speed limit. Now, sometimes we want to do something else. We can run that just fine, and if we run it, we will see braking getting output. But we also sometimes want something else to happen if that condition is not satisfied. So we can actually go back and indent. We can dedent the code like this, and then we can put else colon. So now in this block, this will only get executed if this is not true. So if this is not true, we might want to maintain the velocity of the car like this. Now if we run this, it's just going to break because obviously the car speed is greater than the speed limit. We can test multiple conditions in our if statement by doing this. Let's actually slow our car down. Car speed equals 20, speed limit equals 30. Now, if car speed is greater than the speed limit, as before, we're going to brake. But sometimes, rather than just having if and else, sometimes we want multiple if conditions, essentially. So we can use this else if or elif condition. So now, if the car speed is greater than the speed limit, do that. But otherwise, if the car speed is less than the speed limit, then we actually want to accelerate. And then finally, else print maintaining velocity, like this. So we can actually test these multiple conditions, and if none of them are true, we can just maintain our velocity. Now we can actually keep doing elif statements. We can test more and more conditions, and then finally have our else. But here, if we run this, we're going to get accelerating because of the fact that the car speed is lower than the speed limit. So this evaluates to true, so this code block is executed, everything else is ignored. Now, as mentioned previously, we can actually combine Booleans using comparison operators. So a practical example, we might want to exclude certain types of vehicles. So let's say our vehicle is going quite fast. Car speed equals 50. And speed limit equals 30. But now let's also introduce vehicle type. And I want this to be emergency. So this is an emergency vehicle. It's a police car, something like that. So let's create a condition. This time I'm going to put parentheses because I know I'm going to group these together. You'll see in just a moment. But to start with, let's just create a condition like this. Car speed is greater than the speed limit. I want to brake as before. If not, I want to accelerate. So now you'll notice that the car is braking. However, we've got a vehicle type which is emergency. So we might not want to brake if it's an emergency vehicle. So what we can do is, we know that the variable here is basically going to evaluate to true, so it's going to print breaking. So what we can do is we can combine conditions by saying and vehicle type does not equal emergency. So what is this doing? This car will only brake if it's both above the speed limit and the vehicle type is not emergency, as in it's a normal vehicle or something. However, here the vehicle type is emergency, so this is going to give us false. Remember, true and false is false, so this statement will not execute, and therefore this one will. Now, we can actually nest if statements. We can do something similar to the code in the prior block. However, it will be slightly different because of the fact that it's possible to get no output. But let's try to write this a bit differently. We could do car speed equals 50, speed limit equals 30, and vehicle type equals emergency, as follows. Now again, let's create a condition. If car speed is greater than speed limit, what I actually want to do now is, if the car speed is greater than the speed limit, I then want to test if the vehicle is an emergency vehicle. So now I can have another if statement in here. If vehicle type does not equal emergency, and you don't need the parentheses necessarily, but I like them. So if the vehicle type is not emergency, then I want to brake. Otherwise, I want to accelerate. So we've actually created a nested if statement here. It's similar to the previous example because if I run this, it is going to give me accelerating. The difference is that here we're testing both conditions, and the only two outcomes of this is either braking or accelerating. However, here, because of the order in which we're doing it, we're testing car speed greater than speed limit first, and only then are we checking for the vehicle type being emergency. So what that means is, if this condition is not true, and to do that, let's just increase the speed limit to 60, it's actually going to give us no output because it doesn't enter this code block at all, and there isn't an else here. If there was, it would run that. So you have to be careful about how you want to actually combine your conditions. It depends on the functionality you want from your program. If you want to always get some kind of output, you will want to write it this way. You can mimic this by just adding another else statement on the end of this if block here to try replicate it. Now, one thing to note is that the condition in an if statement does not actually have to be a Boolean. It can be something that converts to a Boolean instead. Now, these values in Python have certain names depending on what Boolean they would actually convert to, and they're called truthy and falsy. So what we'll see is, whoops, my keyboard is shouting. So what we'll see here is that if we run the bool function and we give it some numbers, let's say print bool 10, print bool -5, and let's try 0. Now what this gives me is true, true, and false. What this is saying is that numbers that aren't equal to 0 are actually truthy, whereas numbers that are 0 are evaluate to false. Now let's try another one. This is going to be quite a common example. So let's do print bool of an empty list. I'm just going to open and close some parentheses, and then let's try the same on a populated list. You see that the Boolean version of an empty list is false, but a populated list converts to true. Now, these can actually be used directly as conditions in an if statement. We don't actually have to convert them to Booleans at first, and this syntax is quite common. So let's say we have a lonely list. It's not populated, so what we're actually going to do is create an if statement by just doing if lonely list. That's it. So here, all we're actually passing is an empty list. So if lonely list, we're going to say I am full. Otherwise, we're going to print I am empty. Now, whoops. Now you'll see it's actually evaluated as I am empty, and that's because lonely list is an empty list which is going to evaluate as false, as we saw earlier. So this syntax is actually quite common to test if a list is empty or not. You can be a bit more explicit. If you wanted to, you could get the length of a list as follows. You could do len. In fact, let's do it here. Let's just change the condition. Instead of just putting the list in there, let's do if lonely list, and let's take the length of that list, is not equal to 0. That should give us the same functionality. If I spell it correctly. That should give us the same functionality. So this can be considered a bit more explicit, but in Python it's very common practice to just use truthy and falsy variables and pass them directly into the comparison like that. That's not the first time I've done that. There we go. So now we're going to look at loops, and this is going to be quite interesting because it's going to take us back to collections that we saw earlier. So we're actually going to use these collections and iterate over them. Hi there and welcome back to this tutorial. In this chapter we're going to look at loops. So sometimes we want our code to execute multiple times. It could be to look at every item in a list or perform an action a number of times based on a condition. The two main types of loops that we're going to cover here are for loops and while loops. So for loops allow us to iterate through a sequence, and while loops repeat code while a condition is true. So we're going to start with for loops. These are commonly used to iterate through an iterable. An iterable could be a list or a tuple, for example, but there's also other list-like objects, and we've seen a couple of them before. The loop begins by setting a target variable to the first element of the iterable. Now, when the statement in the loop completes, it restarts, and then the target variable is set to the second element, and so on and so forth. Inside the loop, we can actually do what we want with the target variable. We can print items one by one, or we can do some more complex things, which we're going to see shortly. But for starters, let's create a list. Let's create a list of colors. Let's go with blue, orange, yellow, and neon pink. Why not? Now, the syntax for creating a for loop is quite straightforward. What we do is for, now we set a variable name. We can actually call this anything we want because it's just going to be set to each item in the list one at a time. So I'm just going to call it for color. For color in list of colors, just notice I've missed the S here. So for color in list of colors, and here we can start doing anything we like with this color variable. This is going to be set to these items one at a time. So here I'm just going to print it. We're going to print color. So what this is going to do is it's going to set color to blue, and then it's going to print color. We've reached the end of the loop, so it's going to restart. Then color is going to get set to orange. We're going to print orange, etc., etc. If I run that, it will execute that print command 4 times. So we can perform operations on large lists of numbers using loops. We can take a list of numbers, square each element. Now, often we might also want to store our results in an output list instead of just printing the numbers to the console. The advantage of that is that we can then take that list and use it elsewhere in further computations. If we just print it, we can't actually do anything with it. It's not stored for us. Like, for example, this blue, orange, neon, pink, I can't take these values. So what we can do is we can create a new list and we can append items to that. We've seen the append method before, so this is where some of these things start coming together. I'm going to create a list. I'm going to create all numbers. And we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, I want to create an empty list. This is the list that we're going to populate with some new numbers. And these new numbers, we're going to do some modifications to these numbers. So let's just create an empty list. So now we have that defined. What I want to do is I want to go for number. You can call that what we like. In old numbers. Now I can take these numbers one by one and do something to them. So I can say, new number equals number to the power of 2. This is syntax for doing to the power of, where one number would just multiply it by 2. I'm just going to square each number instead. And then finally, what we can actually do, we've computed this number. We can now add it to our list we've just made. So we can do new numbers dot append new number. Alternatively, we can actually just drag this and put that here. We don't actually have to define that variable, and then we can just get rid of that line. So what we're doing here is we're going through each number. We're going through each number in the list one by one. We're squaring it, and then we're appending it to this other list. So now we're done. Let's get out of that loop by dedenting like this. So now Python uses tabs and indents to denote code blocks. So everything that's indented is going to be in this for loop. So if we want to get out of that for loop, we have to dedent. So now let's just print the new numbers once we're done. And we'll see we've got 1, 4, 9, 16, 25. These are the square numbers of these. So you can see that this can be quite powerful. We've created a list, and with very little code really, we've squared every number and we've returned that list. Now, what if we actually want an ordered list from 1 to 10 like this, but you saw I had to kind of laboriously type it all out? What if we wanted it to go to 100, for example? Or what if we wanted every other number or even numbers only? Python has some built-in functionality for that. It's called the range function. Now, the range function generates range objects for us. It doesn't generate lists. It's list-like, however, and we discussed that earlier. So they are iterables. In order to actually generate these, I'm just going to print it. We use the range method. This range function takes 3 values. It takes a start, it takes the length of it, and it takes the step size. So let's have a look at an example. If I do 0, 10, 1, like this, this gives us this range from 0 to 10, and we'll see what that actually looks like in a second. But if we provide just one value instead of all 3 of these, what it will do by default is it'll create a range. It will start by 0 default, and it'll have a step size of 1 by default. So these are the default parameters. So I don't actually have to specify these. So what I'm going to do is I'm going to print range. Let's change it to 5 this time instead of 10. But you see I get the same thing. So I can omit these if I want to. However, if I want to start elsewhere, start at 1 or change the step size, which we'll see in a second, then I do have to specify these parameters. Now, we can actually convert these to lists, but as I mentioned earlier, we often don't actually need to do this because we can actually insert that range iterable directly into the for loop, and it would work just like a list would. But let's convert it to a list anyway. Let's do list range 0, 10, 1, just like we had earlier. You see, this gives us a list from 0 to 9. The reason being, the 0 is the start, the 10 is the length of the list, this has 10 items in it, and the 1 is the step size. Let's take that and let's change this to 2. Now we go from 0 to 2 to 4 to 6 to then 8. So we are missing out the odd numbers. So this might be how you get all the even numbers. Or if you want all the odd numbers, you might start at 1 instead, for example, to get 1, 3, 5, 7, 9. Play around with that, but that's quite straightforward in a sense. Now, we can actually use these, as I mentioned earlier, directly in a for loop. So let's do something similar to what we did before, except this time, 2 things. We don't have to define that list manually. We can use the range function. And this time, let's actually take a step size of 2 because we can. So I'm going to create my new numbers list again because I want to append to this. Now, for number in range 0, 10, 2. So I can define that range as a separate variable if I want, or I can just put it directly in here. So now it's just going to take every number in that range, and we don't have to convert it to a list. So what we're going to do here is we're going to take our list, new numbers, dot append, and we're going to do something similar to before. We're going to just square every number. Finally, let's get out of the for loop and print those numbers. And you see we get 0, 4, 16, 36, and 64. Now note that if we want to loop through a list, say a list of strings, we don't actually have to iterate through it directly. Instead, we can set up a range and index items from the list. So in that case, we will actually want to produce a range equal to the length of the list, because this gives us the indices of all the items in that list. Now, if that doesn't make too much sense, don't worry, but let's look at it in practice. I'm going to define this list of animals. We're back to this again. Turtle, elephant, hippo. I'm going to try to find a few here. Mountain lion, because we haven't had that one before. And there we go, there's our list. Now what I can actually do is I can print a range. Now I can actually pass the length of this list. Because remember, the range method, it expects one number at least, and that's going to be the length of the range that you want to generate. And the length of the range I want to generate, in this case, I want it to be the length of the actual list, because then this is going to give me some numbers from 0 with a length of 6. So it's actually going to go 0, 1, 2, 3, 4, 5. And that corresponds exactly to these indices. So that's quite a common thing you're going to see in Python. Because now what we can do is, instead of doing for animal in list of animals, which we could absolutely do, we can instead do for index in range len list of animals. So instead of getting the variables one at a time, like turtle, elephant, hippo, instead I'm actually just going to get some numbers one at a time from 0 to 5 in this case. Now instead I can do this. I can print list of animals, and I can pass it that index using slice notation. So think about what's going to happen here. Before we run that, let's add a cell up here, and let's convert that range we just made to a list. So I'm going to do list like this. So we're actually creating not 1, 2, 3, 4, 5. So this index is going to be 0 at the start, isn't it? So I can now do list of animals, and I can pass that index to that list instead of iterating through the animals directly. So what this will now do is it will print list of animals 0, and then 1, and then 2. So what we'll see is it will print the animals one at a time. This is just like doing for animal in list of animals. However, we can make things quite interesting here, because what we can do is, now that we have the index instead of the string directly, we can actually do things like referring to the index before. So I'm actually going to add something to this. I'm going to do some string concatenation here, add a dash, and then I'm going to add list of animals. And instead of referring to the index I'm looking at, I'm going to look at the previous index. So if I run this, look what happens. The first element in this range is 0. So it's going to give me turtle, because that's the first one, hyphen, and then it gives me walrus. And the reason for that is because, remember, Python supports negative indexing. When you pass -1, it starts from the end of the list. So -1 actually refers to this. So then what about the next one, elephant, turtle? Well, that's index 1. And then 1 minus 1 will give us the first element again. So we get elephant, turtle, and then hippo, elephant, and then mountain, lion, hippo, whatever that's supposed to look like, etc., etc. So you can see we can start doing some interesting things if we instead go through the loop using indices instead of iterating through the iterable directly. So a lot of languages might not support this idea of negative indexing, in which case you might be in trouble if you start doing list of animals -1, which is what would happen on the first iteration here. To combat this, you might want to start your range at 1 instead, or you can do something called catching the exception, which is something we'll see shortly. But there are a few different ways of handling that. But as long as you understand this type of notation, this will come over time if it is a bit more complicated, because we're fundamentally doing the same thing. However, instead of iterating through this directly, we're just iterating through some numbers and then referencing this list, which is just an alternative way of doing it, really. So next, we're going to look at some loop control statements. We're going to look at this before moving on to the next type of loop. Sometimes we actually want to interrupt the execution of a loop, and there's two statements we're going to look at here. There's the break statement and the continue statement. So the break statement, it terminates the loop and then transfers execution to the statement immediately after the loop. So if we encounter a break in here, it's going to ignore the for loop and move on to whatever is below. Now the continue statement, it terminates the current iteration only. So if it encounters a continue, it's going to be like, right, I'm not going to run the rest of what's in the for block. I'm going to just go back to the start and start on the next iteration. So they're similar but different in the sense that one terminates the for block entirely, one terminates just the iteration. And we'll see examples of this here. So let's say for a moment that we have our list of animals. So I'm going to redefine that again, although we want plural versions this time. So I'm going to do list of animals equals turtles, elephants, hippos, whales, donkeys, and walruses. I don't know if that's right, but oh well. So let's iterate through these. For animal in list of animals, so one at a time I'm going to get my animal and I'm going to print something. I'm going to print using an F string this time. Remember we looked at these earlier. These are just strings where we can actually insert variables. So and remember we insert variables using these curly braces. I'm just going to take the animal variable. So one at a time, we're going to iterate through this, and on each cycle we're going to print what we see in this list. So far so good. So we've looped through the list and printed out each element. Now we can actually add a continue statement. So what if we don't like elephants? This program is lying to us. So instead what I'm going to do is I'm going to start my loop again. For animal in list of animals, I'm going to add an if statement in here. If that animal is an elephant, I want to run continue. This is the first of the loop control statements we're going to look at. Otherwise, I'm going to do exactly what we did before. I'm even going to copy paste it. So what happens here? I also want to just print something at the very end, just so we can see when the loop is finished. So we can see that it has actually included elephants, and the reason for that is because these are plural and I missed the S, so don't mind me. If I run that, you can see elephants has disappeared. What's happened is it's looped through each one. It started with turtles and printed this. When it got to elephants, an animal was defined as elephants, we ran continue instead. Now this just skips that iteration and then it carries on. So the one after that was hippos, so it carried on with that. Now, what if we take that exact same code and instead use the break statement? And this is why I've added print finished at the bottom. So if I take that and just change this to a break, what happens? This time it goes through the loop. It starts with turtles and then it gets to elephants. And when it does, it breaks. That means that the entire for loop is finished. It no longer continues iterating through the iterable. And then we're finished. So they have different uses. Break statements are useful if you're trying to find an item in a list, for example. Like if you were looking for turtles, well, you've just found it. You don't need to search through the rest of the list. But continue is also useful if you want to handle specific cases. For example, in this case, where if this certain thing is encountered, we want to ignore that. In a more formal setting, we may not want to do processing on a certain data set, for example. So if the name of the data set matches something, then ignore it and continue on with the next data set, for example. So those are useful statements that we might use in for loops particularly. Now we're going to move on to while loops. While loops continue looping while a condition is true. Now when that condition becomes false, the iterations stop immediately, and then any code after the loop is executed. In the same way the if statement took a condition, the while loop also takes a condition, and therefore we can define multiple conditions by using comparison operators. So one of the first things we can make is a simple counter. So I'm going to define a couple of variables here. I'm going to say counter equals 0 and max count equals 10. We're going to use the keyword while, and we're going to give it a condition, just like we do with the if statement. So we're going to say while counter is less than max count. So the counter is currently at 0 and the max count is 10. So this is going to execute. We already know this, just like with the if statement. What I'm going to do is I'm going to print counter. So counter is 0. while the counter is less than this maximum count, we're going to print the counter. So at the start, it's just going to print 0. And if I ran this, it would just print 0 forever because counter is always going to be less than max count. So what we now need to do is counter equals counter plus 1. So we start at 0. 0 is less than 10, so we print 0. Then we increment it by 1. 1 is less than 10, so we print 1, increment it again. If I run this, it should count from 0 to 9. Moving on, we can look at another operator. And this operator is actually shorthand syntax for something we just did. So a lot of the time in Python, we do this operation, I equals I plus 1, or I equals I plus anything for that matter. We did it just up here, incrementing this counter. Because it's such a common operation, there's actually shorthand for it. If I define I equals 1, I can do I plus equals 1. And if I print I, that increments it by 1 to make 2. It's just shorthand syntax for doing I equals I plus 1. So you will see that. If you prefer writing out I equals I plus 1, that's fine too. So we can also decrement a value. We can say I equals 1, I minus equals 1 instead. And if we print I now, we'll get 0. That's the equivalent of doing I equals I minus 1. Now, there's actually shorthand with these operators in other contexts as well. And if we want to get very fancy, let's have a look at sets again for a second. If I define a set, remember these are created by writing out these curly braces, and we have these unique elements in there. And remember the pipe operator. The pipe operator allowed us to union sets together. So if I have 1, 2, 3, and I union 1, 2, and 4, for example, I will get 1, 2, 3, and 4, because those are the elements that are common to both sets. So remember the union operator. We're going to union two sets together, which essentially combines them and then preserves the unique values. Now remember, union was something like my set is equal to my set union with the pipe operator, another set. So we could do that. Instead, we can use this fancy notation and say my set pipe equals 1, 4. And then if we print my set, this should give us our 1, 2, 3, 4. So we've actually unioned these sets together using the pipe operator, but we've done it with this slightly fancier syntax. It's not particularly common, and don't worry if you would just rather write this out explicitly. It might even be considered better looking. That's really up to you. I just want you to be aware that there are these weird operations. It's quite common to see it when you're incrementing values like this, but maybe less so when you're doing operations on lists and sets and things like that. So now let's use this shorthand in a little example. This will also help us get a bit more familiar with loops. We're going to go back to the car example. So car speed equals 0, and we're going to set the max speed to be equal to 30. Now what we're going to say is while the car speed is less than the maximum speed, we're going to do something. We're going to iteratively increase this speed. I actually want us to print out the speed. I'm going to say, let's do it as an F string. I'm going to say car is traveling at speed, colon, and remember we use the curly braces, car speed, to insert a variable. Now, what I want to now do is I want to increase the speed of the car. Otherwise, we're going to be trapped in this loop forever. Remember, this 0 is less than 30. It's going to print this, and then it's just going to do it over and over again. So what we want is we want car speed equals car speed plus 5. Alternatively, car speed plus equals 5. Same thing. If we run this, it's going to go through the loop the first time because 0 is less than 30, and it's going to tell us it was at 0. Increment by 5, run again, increment by 5, run again. Now, one thing to notice is that it didn't actually reach speed 30. Now, the reason is that, well, it did actually reach speed 30. Car speed did become 30, but it just wasn't printed. And this is because car speed is changed after the print has occurred. So this print happened, it printed the previous value of 25, and then it was incremented to 30, and then 30 was not less than 30, so it didn't enter the loop. So you have to be a bit careful with that. What we can do is we can take this and instead put the print statement after the assignment of car speed. But what this will do, you'll notice, is it does end at 30, but now it doesn't start at 0, it starts at 5. Similar reason. Car speed enters at speed 0, it gets increased by 5 straight away, and then it gets printed out. So it gets printed out as 5 to start with. However, in both cases, car speed does become 30 at the end of the day. And you can test it for yourself if you want. If you just put print car speed after these loops, remember to dedent so you're no longer in the loop. Print car speed, you'll see it's 30 in both cases. The only difference is we're just printing at different times, so it's reporting different things. So that concludes loops. Now we're going to move on to functions. Hi and welcome back to this Python tutorial. Now we're going to look at functions. Functions are actually found everywhere in Python. You've used a lot of them already, like print, max, len, and even the functions that help convert between different types. Functions add modularity to your code. They're supposed to have a single, clearly defined purpose. For example, in some of the previous sections we've been accelerating a car. We might have a function that takes a car object and takes a desired speed and it accelerates it to that speed. That's a clearly defined purpose. It takes a car, it returns a car at speed z. Functions take arguments, and these are the parameters that are passed to the function. And functions can also return something. For example, the max function, it takes a list as an argument, and then it returns the maximum value from that list. So this idea of arguments and return values is something you're going to see in all functions. Some functions don't take arguments, some functions don't return anything, and we'll see that in a second. Now, if we want to define our own function, we can do. So here we're going to look at how to actually create our own functions. We use the def keyword, we name our functions, we define what parameters our functions expects, we add a doc string, we write our code, which is what the function is actually going to do, and then finally we return something if we choose. Let's create a very simple function here. We're actually just going to create a function that adds two numbers together. This is completely useless because of the fact that you can add two numbers together by doing that, but just to demonstrate the syntax, we use the def keyword. We now have to call our function something, so I'm going to call it add, and it's going to take two parameters, x and y. So now whoever calls my function with, say, 3 and 5, x would be set to 3, y would be set to 5. So now I can use x and y in my code underneath. So what am I going to do? Well, I'm going to take the x and y that the user provides and assign it to this new variable called z, and then I'm going to return z. So this is quite simple. It takes this x and y, adds them together, returns that to the user. Now, one other thing we should add is a string up here. This function adds the two inputs together. This is what's called a doc string. It's a string that appears just below where the function is defined, and it can be multi-line if you want, and it allows the user to easily get help about what this actual function is doing. We'll see that in just a second, and there are some standardized way of doing this, but for now we're just going to add this brief description. And I'm going to run that, which now defines our function. Now, let's actually call our function. We can do my sum, because remember, this returns a value, so it's going to return the sum of these. So I can take that value, I can print it directly, or I can assign it to a variable. I'm just going to assign it to a variable here. Let's add 3 and 2, and then let's print that. So we've actually created our own function, and we've fed it some numbers. So 3 has been set to this x value, and 2 has been set to y. They got added together to make z, and then we return z. Now, as we mentioned a second ago, we added this string, we added this doc string. The reason why this is helpful is because if you have your function defined in another module somewhere, maybe someone's imported it as part of a library you've created or something, another user might need some help on it. So what they can do then is they can call help add, and this will tell you it takes these two parameters and it adds these two inputs together. So now what you should really do in here is define what x and y actually are. Are they integers? Are there any limits on the numbers that it expects? So that's going to be helpful for the user rather than just seeing x and y here. Now, one thing to note is there is quite a difference between add without the parentheses and add with the parentheses. The difference is, I'm just going to create a little cell here. The difference is that if I just type add and hit enter, this is an object in Python. Just like integers and strings and floats, add is also an object in Python. It's a function and it can be passed around. It can even be assigned to another variable. So now we can do C and call our function with C instead. So this add object is being passed into help so that we actually get this. Now, if I call add parentheses, this is calling the function. This is actually running the function with the arguments that you provide. Here, we're not actually providing any arguments. So if I run it, it's actually going to complain. It's going to say you're missing the two arguments X and Y. But even if I do put them in, I get 5. If I now did help add 3, 2, I'm doing help 5, which actually gives me the help on an int object because we're passing 5 to this. So you have to be a bit careful about the difference between add without the parentheses, because that is just a reference to the function, it's just an object, and add with the parentheses, which is a call to the function. Now, one thing we touched on earlier is arguments. Now, arguments are things that can be provided in two ways. We can provide them by position, and by this I mean that we provide the arguments in order. So we saw X and Y earlier. You provide 3, that gets set to X because it was provided first. You provide the 2, that gets set to the Y. But you can also provide them by keyword. So we can actually provide these function arguments by keyword instead. Let's look at the add function that we were looking at earlier. If I do my_sum equals add, and we did 3, 2, and then we printed my_sum. So X is being set to 3 and Y is being set to 2 in this function, right? And we are providing them by position because we're saying the first number is going to correspond to this X and the second number is correspond to this Y, because that is the order they are defined in. But what I can actually do is I can say X equals 3 and Y equals 2. Here I'm providing them by keyword. So I'm taking what the variable is called and setting it explicitly like this. And one advantage of being able to do this, we can actually do the arguments in a different order. So we can say Y equals 3 and X equals 2. So we can actually supply Y first. And that also gives us 5, of course. Now, we can also make arguments optional. And the way we do this is we provide them with a default value in the function definition. So let's define another function. Instead of add, let's define multiply. This is going to take two numbers, X and Y, and multiply them. I'm not going to assign it to a variable. I'm just going to directly return X times Y. So it's a pretty useless function again. But I just want to demonstrate. If you want to set a default value, you can say this is equal to 5. So now whenever anyone calls this function, if they don't give Y, then Y is going to be assumed to be 5. So let's define that. Now what if we call this with just 7? It's going to assume that Y is 5. And therefore it's going to do 7 times 5, which is 35. But what if I do provide the other value, like 2? Then it does give me the 14. So you can see here, this allows us to omit values. And you've seen this previously. You've seen it with the range function. Remember, with range, you have to provide the length, but you don't have to provide the start point, and you don't have to provide the step size. Those are assumed to be 0 and 1, respectively. And that's done in exactly the same way as this. So we've seen so far that the function has returned a value. This multiply 7 actually returned this value, which we can then assign to a variable or just print directly. However, it does not actually need to. For example, the print function does not actually return a value. It only prints something to the console, and functions that don't explicitly return a value return none. So let's define another function. Let's define greeting. And we're going to let it take a name and an age, and then we're just going to do a simple print. We're going to do an F string. Hello, my name is, we're going to insert the name, and I am age, years old. Now, this doesn't return anything. We don't have a return string here. We're actually just printing it directly. So now, if I call greeting, and let's call greeting with Claire and 50. Hello, my name is Claire and I'm 50 years old. So one thing to note here is that greeting isn't actually returning anything. So we cannot do anything with this output. It is simply just being printed. If I assign this to a variable, A, it does the print, but then in another cell, if I look at what A is, it's not defined. It's not actually going to give me anything. In a similar way, if I try print the output of this, so the greeting is going to do a print, but then we're going to print what this returns. This doesn't return anything. So your first print is going to give you that output, and then your second print is going to be none. And we can see here that if we just type that out again by doing output equals greeting Claire 50, that will run, but then now we've assigned none to output instead. So if I print output, that output will actually have a value of none. Now functions can return lists, sets, tuples, or any Python object, including other functions as well. It's common to see functions that return multiple values as well. So let's try that. Let's create a little function here. I'm going to import random. You saw this earlier. I'm going to need some random numbers here. I'm going to define a function called perturb, and this is going to take two values and it's going to make a slight modification to them randomly. So I've got my x and y, and now I want my new x. New x is random dot, and now I want a random number. I'm just going to take a random number between 0 and 1. So let's do random. Plus x, and then I'm going to do new y equals random dot random plus y. So we're going to get a random number between 0 and 1, and we're going to add it to our inputs. Now, in order to return multiple values, all we have to do is return new x, new y, like this. We could add them to a list, and we could return the list if you like. Alternatively, you can return them like this, and you might see this. Now, this will actually return as a tuple. So if I run this, let's do print perturb, and let's do 3, 5. This gives us a tuple. Now, tuples actually have a special ability in the sense that they can be unpacked as well. So if you actually want these as separate numbers, what you can do is you can say a comma b equals that tuple. So you can just run the perturb function with our 3 and 5 again. And what happens now is a and b are actually assigned to these values respectively. So let's print them one at a time. Print a and print b. So you've got a few different options in terms of flexibility here, how you want to output. You can output these as a list. That might be personally what I would choose to do. But this is also quite common. And you can see we've passed in our 3, it's had this random increment to it, and the same thing with the 5. So one thing I want to quickly discuss now is this idea of passing by reference or passing by value. In pass by reference, the things are actually passing to functions are only references to the underlying object. That object lived somewhere in memory. It has a certain memory address, and the thing you're passing it is only a reference to that object. So if you now use that reference to make a change, that changes the underlying object, and therefore if you then look at that object outside the function, it will have changed. Pass by value is a bit different. In pass by value, when you pass a value to a function, the value is copied. It creates a brand new object at a different memory address on your computer. Therefore, if you change your object in the function, it's not going to change outside the scope of the function. Now, it's a bit weird I've told you that because Python seemingly does neither of these. Python passes by something called object reference, and the details are a bit beyond the scope of what I want to talk about here. However, in practice, what it means is that mutable objects like lists, when we change them inside the function, they will change outside the function. However, immutable objects will not be changed. It's just something to bear in mind when you're using functions. Let's have a look at it in practice. So if I create a list, my list equals 1, 2, 3, and now we're going to create a function that modifies this list. We're going to define append to list, and this is just going to take a list of some kind, and it's going to do some list dot append 4. Again, pretty useless function. It doesn't return anything, it just appends the list you give it. So let's print the list first. We've not called the function. Let's print the list first. Now I'm going to run the function. So I'm going to do append to list, and I'm going to pass it the list I just defined. Now that append has happened inside this function, right? Inside the scope of this function. However, and I haven't returned anything either. I haven't said my list equals this thing. I'm not doing any assignment. But what I'm trying to illustrate here is that I'm passing a reference to the underlying list object. This is now using that reference to make that modification. And because this is referring to the same list as here, it's actually going to change this list. And let's demonstrate that with this code. I'm finally going to print my list. So I'm printing my list before. I'm now modifying it in a function elsewhere, and I'm printing it afterwards. You'll see that it has actually changed. It has modified this my list. This change has happened even though we haven't reassigned my list anywhere. That's important to note. Now, what if we now do a very seemingly similar example, but instead of with a list, let's do a number. Let's have my number equals 5. And we're going to define add to number, some number, and all we're going to do is take that number and do some number equals some number plus 1. We're not going to return anything. We're just going to take this object reference and use that to access what's at that memory address, add 1 to it, and then store it to this variable. Very similar to what we were doing before. Now, if I print my number, now let's modify the number. So add to number, let's give it the number 5 we've just made. So inside the scope of the function, this will change it to 6. But now let's print my number again. And here you'll notice that it's 5 both times, even though we've basically done the same thing as we were doing here. Here, this is because integers are immutable. So a copy is created. And so when we assign 5 to some number here, this then becomes 6, but nothing actually happens to this. It just remains in the scope of this function. And we made a copy of it, therefore it does not modify what was at the existing memory address. Note that that works differently with immutable objects like we saw here. Take some time to digest that if you need to. However, just make sure that you're aware that mutable things can be modified by functions, even though you're not doing reassignment. Now, we've looked at some basics of functions here, and we can actually make them quite complicated. You first must consider whether you actually want your code to be a function. Would the function serve a clear purpose? Would it be reused elsewhere? And would it be something useful that is easier than a native solution? So we've seen here, we've been creating functions that add numbers together or things like that. That's pretty useless because you can easily do that by just using the plus operator. You really don't need a function that does that. We might want to only create functions that serve a particular purpose and that are sufficiently complex enough. What I'm going to do here is I'm actually going to add a little example of a function. I'm going to cut for a second and you'll see I'm going to add a rock, paper, scissors function. Right, so I've written the rock, paper, scissors function. I've imported random because I'm going to use randomness to decide what the opponent actually picks. So I've started by defining RPS and I expect this move parameter. Are you going to pick rock, paper, or scissors? I expect this to be passed as a string. And then I've got a doc string here also saying specify your move as rock, paper, or scissors. So the user knows exactly what to pass. Now, one thing I started by doing is to actually make the input all lowercase, just in case the user specifies rock with a capital R and things like that. Now we define a list of valid moves, so rock, paper, or scissors, and then I want to pick a random move for the opponent. Thankfully, in the random library, there's this random.choice. Random.choice is useful. You give it a list, like this, which is rock, paper, or scissors, and it will select one item at random from that list. You'll also notice I've commented a lot of the code here as well, which we haven't been doing previously, just to make this slightly more complex function a bit more easy for you to understand. So now we have two things. We have our move, which we've given, let's say it's rock, and we've also got an opponent move, let's say it's scissors. So now all we have to do is evaluate all the different possibilities that could happen. So here, my move could be either rock, paper, or scissors, or it could be something different. So if it's not one of these, I actually want to print input not recognized, try again with rock, paper, or scissors. That's useful to do because it gives feedback to the user on what they actually did wrong. But you see all of these in this block, there's only 4 different possibilities: rock, paper, or scissors, or the error. So now if my move is rock, we then have to evaluate what happens depending on what our opponent picked. So if our opponent picked rock, it's a draw. If our opponent picked paper, we lose. Otherwise, it's obviously going to be scissors, in which case we win because a rock beats scissors. I'm hoping I've got all these different combinations right. So it's actually nothing you've seen before that's too crazy. It's just a bit more lengthy. It uses this random.choice. But other than that, it's everything you've seen before. It's just a combination of if statements and it prints stuff. So I'm going to run that so the function is defined, and now we can play. We can do RPS rock, and let's run that. I won apparently. So now we can do paper as well, and we can do scissors. Let's see how many of these I win. A mixed bag, 1 win, 1 loss, 1 draw. Now let's try with some erroneous input. Let's do RPS, I don't know, let's do gorilla or something. A gorilla is easily going to defeat either a rock, paper, or some scissors, but our program is a bit sophisticated in the sense that it checks for those inputs. It says input not recognized, please try again with rock, paper, or scissors, because otherwise that is clearly cheating. So that is also a good thing to do, and that's something that is going to make you a good programmer. Not only can you write functions that serve a clear purpose and something that can be reused over and over again, but also does it handle input well? Is it easy for someone to use? If you imported RPS and you started typing random stuff here, you'll see it tells you exactly what to do. Please try again with rock, paper, or scissors. That level of clarity is something that's going to make you a really good developer. So now we're going to move on to exceptions. Hi and welcome to one of the last chapters of this tutorial, and we're going to talk about exceptions. Exceptions is something that's short for exceptional events, and these occur when there's a logical flaw or error in a piece of code. There's a lot of different types of exceptions. Developers can define their own exceptions. Quite a popular exception, I suppose, is when you try divide by 0. So let's do print 5 over 0. This gives you this error, this exception. The name of the exception is zero division error, and then it tells you a bit about what happened. Another example of an exception might be when you try index a list and it's out of bounds. So let's do my list equals 1, 2, 3. And then let's say we want to index the 3rd element, but we pass index 3, which I've done before many times. Remember, Python uses zero-based indexing, so this is referring to the 4th element. It's going to interrupt your program and say list index out of range. Now, exceptions actually interrupt your program and ensure that any remaining code is not executed. But sometimes you don't actually want that interruption. Let's define a function here. So we're going to get more practice with functions. I want to define this function called reciprocal, which takes a list of numbers. Now, what I want this function to do is it takes a list of numbers and then it outputs a new list which has the reciprocal of all the elements in that list. So by reciprocal, I just mean 1 divided by that number. So I'm going to create my output list. We've seen this style before. Now I'm going to do for number. So I'm going to create a for loop because I want to take these reciprocals one at a time. So for number in list of numbers. So now I've got my number, so I'm going to get the first number that the user has provided. I'm going to do output.append because I want to append my result to the output list, and I'm simply going to do 1 divided by the number. So we're going to loop through the list one at a time. We're going to do 1 divided by that element. We're going to add it to the output all in one go because we're good at Python now. So we can do that without assigning any variables. Once we're done with the for loop, we actually want to return that output. So now when someone runs this function, they're going to get this list and they can print it or they can assign it to another variable. Let's run that and it'll define that function. So now let's print the output of this function. reciprocal, and let's give it a list, 1, 2, 3, 4, 5. So you can see 1 divided by 1 gives us that 1, 1 divided by 2 is a half, and then we get a third, a quarter, a fifth, and so on and so forth. But now let's say we pass a 0 by accident. So I'm going to take this list, and after the 3, let's add a 0 here. You get an error. You don't get the print at all, and it tells you there's been a division by 0, which is fine. It's what you expect. 1 divided by 0, it's not something that can happen. However, this has actually interrupted our program. It's not given us an output. Imagine you've spent a bunch of time creating some complicated pipeline. You run it overnight, but one of the rows that you're processing, one of the rows of data, has some corrupted data, or it has a 0 in it, in which case you get that 0 division error. And so that completely interrupts your program. You don't get an output. You've just wasted all of your time, basically. So what we can do is we can learn to handle the exception. And we can catch the exception, and we can catch it using a try except block. Once we have that exception, we can handle it however we want. This depends on the situation, but one suitable way here might be to append none to the list and maybe just print a warning, for example. So let's do that. Let's take our reciprocal function and let's improve it. So I'm just going to copy paste that here. Now, instead of doing this output.append 1 over number, because 1 over number, if number is 0, it's going to cause a problem, right? Instead, what I'm going to do is I'm going to try do that. So I have to indent this now. So it's in the try block. I'm going to try do that. So it's going to try and do 1 divided by 0 and then append it to the list. And then we're going to have this except statement. Here we need to specify the exception we actually need to catch. So in the try statement, if this exception occurs, we go into this statement. And the one we want to catch, we can just get it from the error message. It's called 0 division error. Except 0 division error. Now in this block, if we see a 0 division error in our try statement, we're going to do something. Rather than interrupting the program, we're just going to say print warning. Could not divide by 0, appending none to output. So now what we're going to do is instead of output.append 1 divided by 0, we're going to do output.append none. So now this tells the user, you gave me a list of numbers, there was one that was 0, I've appended none to the output. So I think we've handled that appropriately there. So now let's try calling this once again. The exact same thing, we've got a 0 bundled in there somewhere. We see it gives us our warning. Could not divide by 0, appending none to output. But you also see it has processed the rest of the data just fine. We've got 1, 5, 1, a half, sorry, a third, a quarter, a fifth, and that 0 has been replaced by none. So now that we've got this list, we can get rid of the nons, for example. We can do whatever we like. Now, one thing to note is that we can also use this try except functionality without actually providing what exception we want to catch. So for example, we can do try 1 divided by 0 in this case. This will raise an error, so it's going to run what's in the except statement. But this time I'm not going to specify the exception. I'm just going to say print you divided, or you tried to divide by 0. And if we run it, we get that error. The problem with this is regardless of what error occurs in here, it's going to trigger the except statement. So we might actually have a completely different error here. We might be indexing a list and that index is out of bounds, but it's still going to divide by 0. So you need to be a bit careful when using this, and it's generally considered bad practice. You can actually provide multiple exceptions here, so you can do 0 division error and then you can do index error. You can actually provide multiple like that if you need to catch multiple and do the same logic, but providing a sweeping except statement like this is considered bad practice, and I want you guys to keep away from that if you can. There's different ways of handling exceptions, to be honest. We could use this try except notation like we have done here, or we can use an if statement, to be honest. So we could have if number equals 0, print warning, append none. We could do the exact same thing. But exceptions are useful in their own right, and sometimes it's useful to even throw an exception, and we'll see that in a second. But just before that, we're going to look at the finally block. I'm actually going to take this again, except this time I'm going to do it properly and add a zero division error here. Zero division error. So only when a zero division error occurs does this trigger. Now with the finally block executes regardless of whether an exception occurs or not. So this means that even if our program succeeds, this is going to run. So I could put print ending program, for example. So here, because we tried doing 1 divided by 0, it says you tried dividing by 0, and then it also triggered what's in the finally block. That's useful if we need to, you know, we've handled our exception and now maybe we need to close down the program or close a file or something like that. Now sometimes we actually want to raise an exception manually. Maybe we validate a user's inputs like we were doing before with the rock, paper, scissors example, and we see that it's not valid. We can then throw an exception which allows the caller of that function to then use a try catch block on their side and handle it in whichever way they choose to. And based on that, we can actually even define our own exceptions. We can have a rock, paper, scissors exception if we really want to. It's not something we're necessarily going to cover here, but here's an example of just how you might throw a more generic exception. You can do raise exception, which is just a general exception class. And we can also provide some detail. I'm going to put invalid file error. The file provided is not the correct format. And if you just run that, you just get the error. Notice that it is just that generic exception, even though in the string I've tried to sort of mimic an exception. But you can actually define your own types of exceptions. That's something I think you can look into if you like, but it's beyond the scope of this course. So now we've come to the end. This has been a course to help you master the basics of Python. If you're a complete beginner, it's also given you that gentle introduction to programming, because I feel Python is a very friendly first language. It's a very good choice for a first language. And using Python, it's also quite powerful as well as being simple, because there's so many other libraries that we haven't looked at here. We've just looked at basic Python code, basic syntax, loops, different types of objects and things like that. So that's very helpful in the sense that now that when you go look at other Python code, it's going to be very familiar to you. And even when you are using other libraries, you're going to be able to use some of these things. You're going to obviously use lists and loops and conditions all of the time. But a good next step might be to look at external libraries, because with these we can start doing some quite powerful things. We can do machine learning. We can take some data, maybe create a few lists of data and then plot some graphs using that data. We can manipulate data at scale. We can use a library called pandas, which is essentially Excel in Python. You can do a lot of tabular data manipulation. We can make graphical user interfaces. We can make games. We can do all sorts. And all you really have to do is Google the library, read some of the documentation, which will hopefully go through examples of how you use it. And because you're now familiar with basic syntax, you're going to be able to incorporate that into your programs alongside loops and lists and all the other things we've covered. So I hope that's been helpful to you. I think another thing I want to mention quickly is object-oriented programming is also quite an interesting next step. This will sort of help you understand classes and a slightly different style of programming that we haven't covered here. We've looked at functions in quite a lot of detail, but in addition to that functional style of programming, there is also this object-oriented style, which I may well do a video on, and so that is something I think you should check out if you're interested. So I hope you had fun learning from this course. I hope it's been helpful. I hope you've enjoyed this. Thank you so much. Bye.